Felicita Gali.
Parikh Sahib, good afternoon.
Good afternoon, sir.
Good afternoon.
So you are going to represent your presentation, sir?
No. My presentation is tomorrow. So can I make it today? So Dr. Parikh was mentioning, if anybody is absent, so I love to.
No, sir. Not for that, sir. Actually, we are having some list. So according to that schedule, which have been given to me, you and all, we have to follow that schedule. If anyone is not present in that particular schedule, then we will move to next. Meena ji,
okay.
Please call next person.
I think this is the time for keynote address.
No,
yes, sir.
No, but first session we have not completed, Anandji. That's
okay,
why we are lagging.
Please, sir, go ahead. Go ahead.
So next participant, Mohammad Jamaluddin. Mr. Jamaluddin.
Yes, sir. Yes, sir.
He is here.
Please.
Yes, sir.
Please present your paper.
Meena ji, also tell that we are having that particular time, 5 to 6 minutes only for presentation and 1 minute for question session.
Sir, it is visible.
Yeah. Now.
Yes, sir.
So may I start, sir?
Yes, sir. As chairperson of session has already requested that every participant has 5 minutes for presentation and 2 minutes for discussion.
Okay, sir.
Okay, sir. Present your paper, sir, please.
Okay, sir. Very good afternoon to all of you. The title of my presentation is Promoting Problem-Solving Skills of Secondary School Students in Physical Science through Metacognitive Strategies. As we know that problem-solving skill is one of the important skills of teaching learning of physical science in the 21st century. From literature review, it is noticed that students, particularly school students, are poor in physics problem solving as they have not clear-cut idea about how to approach the problem and how to choose the strategies and checking whether the steps that have been done are correct or not to find out the solution. So in order to overcome these problems of school students in physics problem solving, metacognition strategy helps a lot, which helps to reorganize their thinking process in the proper direction. So in this study, one model I have selected, that is Zimmermann model, which consists 3 stages, namely planning, monitoring, and regulating. Every learner or physics problem solver has to pass through these 3 steps. In the planning step, individual passes during the learning in the first stage, where the task is analyzed and proper planning is set up. In the second stage, that is monitoring, where the task is carried out through self-control and self-observation. And the third stage is regulating, where the task performance is evaluated and feedback is reviewed to improve their learning. That is problem-solving ability. Rational. Problem-solving skill is very, very important, but student facing problem due to lack of their appropriate thinking strategy. So in this study, efforts have been made to determine the relationship between metacognitive strategies and problem-solving skills. So 3 objectives have been taken into account. First, to study the correlation between metacognitive planning and problem-solving skills. Second, metacognitive monitoring and problem-solving skill. Third, correlation between metacognitive regulation or regulating and problem-solving skills. And accordingly, 3 hypotheses have been formulated. Null hypothesis: there is no significant correlation between metacognitive planning and problem-solving skills. There is no significant correlation between metacognitive monitoring and problem-solving skills. There is no significant correlation between metacognitive regulating and problem-solving skills of students in physical science at secondary level. Now, variables. Metacognitive strategy have been taken as discontinuous variable, and where 3 strategies, sub-strategies, planning, monitoring, and regulating have been carried out, have been taken into consideration, and continuous variable problem-solving skill, and here gender, male, female, both co-education schools have been taken into consideration. Delimitation, studies delimited to schools in Kolkata municipality, class 9 students, Hindi medium co-education schools, physical science of West Bengal Board of Secondary Education. Descriptive survey method has been used in the study. All class 9 students from government sponsored schools of Kolkata city in West Bengal have been considered as population. Sample 4 co-educational schools, one from each region, south, north, east, and west region of Kolkata city have been selected. Male, female is depicted in the table given below. And tools to assess the different metacognitive strategies related to planning, monitoring, and evaluation. Self-developed closed questionnaire with 5-point Likert type scale and a competency-based test consisting of 20 multiple choice problems constructed on Newton's laws of motion from class 9 books have been constructed and administered for collecting the data, and the data so collected is analyzed through correlation technique, and interpretation were done using SPSS. So these are the results. The first objective was to study the correlation between metacognitive planning and problem solving skill. So the results, we have got a value of coefficient of correlation, that is small r, is 0.9, and which is significant at 0.05 level. So from this result, it indicates that there is a significant positive correlation between metacognitive planning and problem solving skill. In the similar fashion, second objective have also been studied, and results we got value of r, we got 0.82, which is also significant at 0.01 level, which is more accurate, indicates that there is significant positive correlation between metacognitive monitoring. Because in the problem, sir, yes, sir. So, and in the third step, value is this. So, metacognitive regulation is also correlated positively with problem solving skill. So, from all these studies, metacognitive strategy can foster better problem solving skill in physics. So, educational implication, metacognition plays a significant role in enhancing students' problem solving skills. So thus we can say that students with metacognition abilities or metacognition strategy are crucial in getting, and it contributes significantly in promoting students' problem solving a lot. Thank you, sir. Thank you very much for giving me an opportunity.
Okay, thank you, sir. And now house is open for anybody ask question regarding this paper.
Yeah. So this is Dr. Biswal speaking here.
Please, sir, please.
Yeah. So I want to have one kind of clarification from Mr. Mohammed Jamaluddin, that how did you manage that misconception part during your planning phase? Because I believe that there may be so many students having some sort of misconception in physics problem. So how did you incorporate those components in your planning phase? Over to you, sir.
Sir, repeat your question. What's your question? How I managed?
My question is that during your, how did you manage?
Through Google platform, through Google, through online class and Google form. Evaluation for Google form I use.
Hello? Hello?
Write out those
Okay.
through Google form.
Okay, sir. Okay, sir. Biswalji, you need more clarification?
No, Google Forms are not the, this is Google Forms, I don't know how are you managing, but misconceptions are part of our kind of physics teaching learning practices. I don't know, because what you're saying, Google Form, how do we manage? Can you please elaborate? Yeah.
3-4 months back, I did this study. So I taught students in online, in all the 4 schools, few classes taken on Newton's laws of motion, and then I assess their learning through Google Form.
Okay, sir. Okay, sir. Thank you.
Okay, thank you.
So now next. Okay, sir. Thank you.
Thank you, sir.
Now next participant. Thank you, sir. Thank you. Next participant, Shalini Verma, and paper title is Weaving Life Skills Through Physics Teaching. Shalini Verma.
Shalini Verma, are you connected? I think she is not connected. Let us go for next. OP Meena ji.
Ritesh Kumar ji. Ji sir, ji sir, ji sir. Then next participant, Ritesh Kumar ji. Ritesh ji, are you hearing me? Ritesh ji, सुन रहे हो आप?
रितेश जी नहीं है, रितेश जी नहीं है. नेक्स्ट चलिए.
शालिनी जी, रितेश जी दोनों नहीं है. देन थर्ड ममता पाल.
Yes, sir.
हाँ मैम, प्लीज
Okay.
present your paper.
Let's stop the presentation. Those who are sharing this present screen.
So someone else is sharing the screen.
Someone who is sharing.
जमाल जी, स्क्रीन
हाँ जी.
शेयरिंग स्टॉप कर दीजिए आप.
जी 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 सर. जी जी कर रहा हूँ सर.
It is requested to all. After presentation, you have to stop your screen sharing immediately.
So still Jamaluddin sir is sharing the screen.
Now it is okay.
Okay.
हाँ ममता मैडम,
Okay.
प्लीज.
Good afternoon, one and all present in the national conference. My topic for the presentation is transforming physics classrooms through art integrated learning, which is a survey study. I will stop sharing and once again share the screen. Okay. So most of the presenters have already said why there is a need to change the pedagogy. So in this context, I have also done this study, and I found that based on the literature review that most of the physics concepts are abstract and students find it difficult to express. So there is a need to implement such pedagogies that are more student friendly, that is more child-centered and not teacher-centered. And for this, art integrated pedagogy was implemented. Art integrated pedagogy is a pedagogy that in which an art form is integrated in teaching physics. The Kennedy Center defines art integration as an approach to teaching in which students construct and demonstrate understanding through an art form. And due to this, this pedagogy teaches the students how to learn, and it also provides hands-on activities catered to all the domains of learning and makes the classroom environment more joyful and rich in experiences. It also offers wholeness to learning by integrating thoughts, feelings, and actions. Then for the study, 2 objectives are framed, and the first one was to demonstrate an activity to teach physics to art integration in physics, and to study students' perspectives about art integration. So methodology adopted was, the method was, this is an descriptive research method was used in this study. The population comprised of higher secondary students, and out of this higher secondary students, 60 students of class 11 were selected randomly from a CBSE board school, which was selected conveniently from Lucknow city. Tool was a liquid tap scale was used to know the perspectives of the students. It had 9 items, 7 were positive and 2 were negative. The study includes only class 11 students because higher secondary students includes class 11 and 12, but the study is delimited to class 11 students only. So results and discussion. For the first objective, an activity was planned, and that activity included that.
Madam, your voice is not clear. Any technical problem is there?
So the activity planned was, it required 5 toothpicks, water in a glass, a plate, a dropper. The procedure was to press that the toothpicks were needed to be pressed in the middles and arrange them in such a way that they form a floral pattern as shown in the first diagram. Then one can see a circle in the center. In this circle, a few drops of water was dropped using a dropper, and then it took the shape of a star. So this is an art integration because in this diagram you can see the floral pattern, and then it has taken the shape of a star. So why does it occur? Why did it happen? It is due to surface tension or cohesive adhesive forces. So in this way, one can integrate art into teaching physics and make the classroom environment more enjoyable and rich in experiences. So for the objective 2, a survey was conducted, and to know the perspectives of the students taught through physics through art integration, and it was found that 82% of the students liked this method of teaching, and 88.7% of the students found the activities to be very interesting, and moreover 82% of the students thought this that through this method they can learn physics in their own ways, as it provided opportunities to integrate their knowledge of art in learning physics. And meanwhile 90.3% of the students found the art integration in physics very motivating, and additionally 81.6% of the students found the activities to be very engaging. But interestingly, 49.2% of the students found this art integration in physics quite time consuming, and this may be attributed to thinking about the activity, planning activities and executing them. But 48% had opposite views to this. And additionally, and more striking feature, 42.4% students thought that these activities are quite distracting, but 49.8% students thought that these are not distracting but rather interesting. So 42.4% may be attributed that the students are more engaging in maybe more engaged in showcasing their talents of art rather than in learning physics.
Mamtaji, please conclude.
And some more 78.9% of the students felt that that the teacher should be aware of art and its usage, its guidelines and standards of usage in the classroom, because a lot depends on the teacher to design such activities and to collaborate with the students. So the study may motivate the teacher to implement this pedagogy more frequently as it develops, as it is more engaging, more make the learning environment more enriching, and also develop social emotional skills along with the cognitive skills. And apart from this is more important that it inculcates values of our culture among the students. With this, I would like to end by saying that the study may motivate the research scholars to conduct study that may be experimental across sectional study, because if it is effective on one stage of education, whether it is effective on another stage of education or not, that has to be checked. And it may be integrated in other various disciplines of science and other stages of science also. This, thank you very much.
Thank you, Mamtaji. Now house is open for questions.
Inaji, I think there is no question. You can go for the next presentation.
Okay, sir. Okay, sir. Now, next participant, S. Rajkumar ji.
Yes, sir. I am here.
Okay, sir. Please present your presentation, please, sir.
Sure, sir.
Wow,
Visible, sir.
Rajkumar ji, sir, please.
Sir, my screen is. Am I audible?
Yes, yes, yes.
Yes, yes, yes.
Good afternoon to all. Every one of us during our childhood, by default, played with balloons. Seeing balloon itself is a charm for the children. If you allow the child to touch the balloon, they will touch, feel and blow. Their happiness will fly high like a balloon. They will feel very happy. I practice teaching physics with balloon. In my classroom, in this presentation, I will highlight some of my practices. In our textbook of class 6 to 10, most of the physics concepts can be explained with balloon. Here they touch, they feel and perform by themselves. So they get the experiential learning, which they cannot forget in their lifetime. Here there are some of the learning you can see, the pressure experiment, motion experiment, sound experiments, all related to the class 6 to 8. This is one of the beautiful experiment, Boyle's law. If you are trying to teach Boyle's law, most of the students didn't understand because they can't able to visualize the pressure and the volume. By using the balloon, you can easily explain Boyle's law. Put a small piece of inflated balloon in the syringe. If you push the piston, you are increasing the pressure. So you can visualize the change, the balloon inside the syringe getting compressed. So the pressure increases, volume decreases. They are inversely proportional to each other. Like the Charles law. The Charles law explains that the pressure and the temperature are directly proportional. Just keep the balloon in a direct sunlight. After, if you keep the balloon in the direct sunlight, the temperature is getting increased. When the temperature getting increased, the air molecules become high pressure inside the balloon. So after some time, due to lack of space, the balloon will burst. So the child will easily understand the Charles law. Like that, we can explain the Pascal's law. The beautiful law, that is Newton's third law, very nicely demonstrated using the balloon. Blow the balloon, and if you release the balloon will fly like an aeroplane, like a rocket. The air inside the balloon, due to compression, it come out to the mouth of the balloon. When it come out, it pushes the air molecules. Again, to balance it, the outside air molecule pushes the balloon. So the balloon moves in the forward direction. If the child perform this experiment, he or she never forget Newton's law, Pascal's law, Charles' law in their lifetime. And this is one more example for the Newton's third law. This is a balloon spinner. Actually, in juice straw, we have L-shaped straw. If you attach the L-shaped straw in the balloon, after inflating, keep it on the floor. If you release, it will rotate like a spinner, like a chakra, it will rotate. So we can explain Newton's third law. Very difficult for the children to understand Bernoulli's principle. Using two paper cup and a small balloon, we can easily demonstrate the Bernoulli's principle. You can see in the diagram, the first paper cup, I have a small straw attached to it. If I keep the balloon over the paper cup and started blowing to the straw, the balloon will fall down. But in the second paper cup, if you keenly observe, you can see a number of slits on the walls of the paper cup. If I started blowing heavily, what will happen? The air in the center of the paper cup will get evacuated. So there get a partial vacuum. So
excuse me, Rajkumar ji. Excuse me, Rajkumar ji.
Please conclude, sir.
In order to
no, that slides are fixed. Please, make it full slide and show the slides. You are only talking in slide number 1.
No, sir, I am in slide 4, 5, I think. Sir, now my slide, the pressure slide you are seeing. Sir, which slide you are seeing now, sir?
Actually, your slide only first one is visible.
Oh, sorry, sir. I will
Yes, sir. Yes.
and share it again, sir.
Okay, let us conclude.
Yes, sir. Wait, sir.
Yes, now it is visible.
Okay, sir. This is the balloon. This is the experiment of pressure. If you keep your if you keep your one pin and push over the balloon will burst. But if you keep many pins and press the same balloon with the equal pressure, the balloon won't burst. The reason is the pressure is equal to thrust by area. We can easily explain this. Likewise, we can also explain the centrifugal force. Just put a 5 rupee coin in the balloon, and after inflated, if you rotate the balloon, means the coin will stick on the wall of the balloon and it will rotate. It's like a circus, the man in the dead cage riding in a motorcycle. No, so we can explain very easily that the force acting from center to the outside is called the centrifugal force. Like that, we can also explain the transfer of energy, potential energy to kinetic energy. Just put some sticks in the balloon. If you pull down, you are increasing the potential energy. If you release it, the stick will go off. So we can explain the kinetic energy. Likewise, this is beautiful experiment for sound. This is a bottle whistle experiment. Actually, I put a small straw in the bottom of the bottle. If I blow the bottle, means the balloon will expand. So the air inside the bottle will go out. If I release it, due to elasticity, the balloon will get compressed. So the outside air have to reach the bottle, inside the bottle. So the outside air reaches only through the straw. When it enters to the straw get vibrate. So we can hear the beautiful sound of the. This is the trumpet. You can see how beautiful the shape of the bottle is. This is like a funnel. If you blow through the straw attached in the mouth of the balloon, and the vibrating column of the stretched membrane get vibrated.
Rajkumarji, please conclude. Your time is over.
Yes, sir. Concluding,
please
sir.
Conclude. 30 seconds left.
Okay, this is another experiment with stethoscope. We can explain latent heat. We can explain thermal expansion. This is a beautiful experiment for explaining air has weight. During this COVID situation, what I did is I made a mini pamphlet like this and distribute to the students to the WhatsApp group with material required and procedures and all. What the student did is they perform the experiments in their home and send it back to me. So using balloon as a tool, I taught physics to them. More than 30 physics concepts I teach students using balloon. So what I conclude is the balloon is a wonderful tool. Here the children learn physics with balloon. I visualize many changes among the slow learners and average learners. Balloon is not seen as a material for learning, but it interacts with children during learning. They touch, feel, and make it adaptable whenever required. These hands-on activity make the student to learn the concept easier with understanding. And the abstract concepts like Boyle's law, Charles' law, Pascal's law, Bernoulli's principle, all are visualized and learned by the students. During designing of experiment, they tailored and meant according to the need of the experiment. It provides them space for the creativity and imagination. In some experiments, like open balloon experiments, if some air leakage is found in the experiment won't work. So they find and solve the problem. It develops the problem solving skill. No discrimination is noticed between the different types of learners. They all participated and learned science with fun. Thank you one and all for giving this opportunity. The balloon acts as a wonderful medium to teach physics to the children. Thank you.
Thank you, Rajkumar ji.
Thank you, sir.
Now, anybody want to interact with Rajkumar ji? House is open. Okay. Thank you. Now, next presenter is Divyanshi Sharma.
Yes, sir. I am present here.
Ma'am, please present your presentation.
So, just a second. So, is my screen visible to all? Okay, sir.
Yes, ma'am. Yeah.
Good afternoon, everyone present over here. Thank you for giving me the opportunity. The topic of my presentation is understanding of energy harvesting by beam of cantilever. So here, these are the outlines which I'll be covering and I'll be discussing in the further slides. Now coming on to the abstract, we know that what is energy harvesting? Energy harvesting has been recognized as a very promising technology for various potential applications, and it has become very impractical. Energy harvesting are energy storing device from unused to a wasted energy that is being wasted, and we are utilizing that energy in form of a vibrational energy harvesting. Here the modeling and simulation of cantilever is being done. So here we are using Pzt as a material, and we have compared at different frequency response, and we have analyzed the frequency on electrical voltage, electrical and mechanical power has been studied over here. Now the objective, if we talk about the objective, here we are designing an energy harvester based beam of cantilever which will optimize the parameter, and we will be implementing a low frequency response to generate the more output power and the voltage. Now, this is the tool that is being used. We are using here COMSOL multiphysics software. It is a software that is being used for implementing and simulation of many of the physics software over here. So we have used this software. Now, if we talk about interaction, here we are saying that energy is basically an overwhelming need that is in the present and the future world. As we know that energy is limited because of the unconventional ways of use of non-renewable resources. So we are using, we need an alternative. We need a research over it so that we can use that renewable energy into a useful energy. So now the next thing is what is energy harvesting? Energy harvesting is basically, it is the process that is defined as, it is the process by which energy can be deprived from external sources and converted into usable form. Here what we are doing is we are converting the mechanical energy into the electrical energy. Similarly, if we talk about the renewable energy resources, there are various kinds, that is hydro, solar, wind, and vibration. But our main focus is on vibrational energy harvesting. When we are talking about vibrational energy harvesting, there are three mechanisms that can be used for energy harvesting from the vibration. For example, electrostatic, electromagnetic, and piezoelectric. So our basically focus is on piezoelectric beam-off. So now the next is what are piezoelectric beam-off? Piezoelectric beam-off, it is basically a sandwich type actuator in which two layers of piezometric can be laminated onto each other for the support of the beam or the plate. Here the power harvester consists of a piezoelectric beam-off that is clamped at the one end with a proof mass. So as you can see at the one end here, it is a proof mass. On the other end, we are providing a proof mass over here. One end of the cantilever, we know that it is fixed. So we want to know, due to the fluctuation, we will be calculating how the energy can be utilized over here. Here we are using beam of cantilever as a non-traditional geometry, and it is designed and simulated. If we talk about the designing of the Pzt beam, here basically we are using two materials, that is Pzt, and second one is your primary steel material. The two topmost layer and the lower layer is of Pzt 5H, and the middle layer is basically consists of the primary steel over here. Now these are the key elements that is being used in the piezoelectric modeling. So this is how what we have done, the simulation and modeling of beam of cantilever is being done. First, we should be knowing about the device geometry. Okay, what is the device geometry? After then we define the variables. Okay, here if we are talking about the cantilever beam, if we talk about the width of the plate, that is your 14 mm. And similarly, if we are talking about the proof mass, that is the mass we are providing, the weight of the mass is around 12 kilo. Next is the material properties. So we are using two materials over here, that is your Pzt 5H, and the second one is the structural steel. So these are the properties that is being.
Madam, please conclude, please.
Sure, sir. So just within 2 minutes. Next is the we are doing the setting of the physics, we are meshing, simulation, and finally we are getting the result over here. Now this is a small video through which I have shown how the fluctuation has been done and how the frequencies be considering. Now coming on to the conclusion, what we have done basically, we have concluded at different frequencies we have calculated the beam of cantilever movement, and we have found that at 70.5 hertz we get minimum frequency we have considered the output. These are the results. This is the frequency response. Here the frequency response has been observed along X and Y axis. In both the cases, here we are calculating at the maximum point of voltage and power has been observed. That is nearly across 71 Hertz. Now, the next one is, this is the response of your electrical load on voltage and power has been observed. Here, the electrical and mechanical power reaches its maximum value at a particular load, while electrical voltage saturates, reaching at the maximum value. Now, the third one is here that we have seen the effect of the acceleration in cantilever on voltage and power along X and Y axis. Now, these are the various applications in which piezoelectric energy harvester has been used and is being used further as well. So from here, we can conclude that here we have modeled and simulated a cantilever through a piezoelectric. Here we have comparison, the different beam displacement at different frequency was simulated, while we have considered the lower frequency that was 70.5 Hertz. We have seen the frequency response based on that of electrical voltage, electrical and mechanical power has been seen. In addition, the effect of electrical load and cantilever acceleration on the voltage and mechanical power has also been studied over here. So that was all about. Thank you so much.
Thank you, madam. Thank you.
Thank you, sir.
So, house is open for question.
I have a question.
Yes.
Please, sir. Please, sir.
Ma'am, which modules have you used in COMSOL multiphysics, and which physics have you used?
So in COMSOL multiphysics, we are using structural mechanics over here.
Okay, and which physics have you used?
I have used structural mechanics. In structural mechanics, I have been using frequency response over there. Basically, the model is divided into solid mechanics. So solid mechanics, in which solid mechanics, I'm using structural physics. So that is the main module. If I talk about that is
okay.
the
Okay,
solid
thank
mechanics.
you. Okay, thank you.
Thank you, sir.
Thank you, madam. Thank you.
Thank
Now, next presenter is Amlesh Kumar ji.
Yes, sir. Yes, sir. Good afternoon, everyone. Am I audible, sir?
Yes, sir. Yes, sir. Please present your paper, sir. Please.
Sir, my screen is visible.
Visible, sir. Please, sir.
Okay, thanks.
Yeah.
So, myself, Amlesh Kumar, research scholar, Regional Institute of Education, Bhubaneswar. So, my paper entitled is Sustaining Learners' Interest in Physics and Exploratory Study. Through this paper, actually, researchers have tried to explore how we can sustain learners' interest in physics. Even we all are aware how physics is as much as important in our schooling process, and even after schooling also higher studies. So even several studies they have reveal a lot of difficulties students they are facing in physics, even initially in high school days due to the kind of teaching learning practices we have, traditional teaching learning practices, and a lot of issues we had revealed throughout this paper. So sustaining learners' interest in physics is one of the most important aspect for educational process if you want to produce more learners in physics, more researcher in the field of physics. So my objective of this study was to study the views and understanding of teachers on how they can sustain learners' interest in physics learning, and to examine the factors which influence learners on sustaining their interest in particular physics, to find out the different ways and means how teachers can create those kind of interest among learners related with learning of physics. So these were the my objectives of the study. And even in this study, I had used a descriptive survey method. Even a purposive sampling technique was used for this study. And for this study, I had collected data from pre-service teachers as well as in-service physics teachers, and 58 pre-service teachers and 6 in-service teachers were the participants of this study. And an open-ended questionnaire and semi-structured interview was used as a tool for this study. And the data gathered were analyzed by qualitative analysis technique. Even this study had found different views and opinions from the participant why physics is so much difficult for learners, and why learners are even disinterested towards learning physics. So in the opinion of participants, even there are a lot of issues they had raised for this interest regarding the physics learning, like lack of ability to adapt the physics knowledge in new situation, inability to create a link between physics learning and the day-to-day activities. Even we have that old physics curriculum, which is not connected with a new advancement and technological way. Even limited seats are available, higher studies in physics and in research area. Even inability to understand physics is the foundation for technology and advancement. Even lack of awareness among students about a scope of physics and career in physics. So these are certain barriers even around teaching method. Even teachers are not teaching as per the learners need, even based on content, based on learner, and based on context. So these are the major barriers for this investment in the physics. Even participant had suggested some of the ways how they can create interest among physics, like they can identify students with aptitude and interest in physics, and teachers can mentor them. Even need to train physics teachers that how they can sustain learners' interest in particular physics. Even need to clarify
please conclude, sir, please.
Yes, need to clarify the scope of physics among the children. Yes. Even certain ways and means through we can sustain learners' interest in physics, like, and we can improve present physics teachers' abilities, knowledge. We can impart certain skills to the teachers, how they can transact meaningfully in the particular physics concept, to adopt appropriate approach and strategy in teaching physics. We can teachers can encourage active student engagement in class discussion. We can create a better system for physics teaching learning practices. We can use a real world example to make physics learning more interesting for the learners. We need to go with proper learner-centric teaching learning practices in particular physics. And this study had concluded, like found that if we can use these learner-centric teaching learning practices, and if we can use various strategy and approaches in teaching physics particular, if we consider content learner and a specific context, then we can connect learners in physics learning. We can use ICT, we can use community resources available in our surroundings to teaching physics. So these were the certain findings of the study through we can create and we can sustain learners' interest in physics. So thank you so much, sir.
Thank you, sir. Thank you. Now, house is open for question session. Okay.
Vidaji, go for next presentation.
Okay, sir. Okay. Now, next presenter is Arvind Raja.
Sir, good afternoon. Am I audible?
Yes, sir. Yes, sir. Please present your paper.
My screen, sir. Is my screen visible, sir?
Yes, sir.
Sir, this is D. Arvind Raja. Good afternoon to all the dignitaries of this national seminar present here. I am D. Arvind Raja, working as a teacher in Achuna Subrahmanya Naikar Government High School, Modapet, Puducherry. My topic for the presentation is physics through bubbles. Every child loves blowing bubbles. From kids to adults, we love bubbles. We love to play with bubbles. Blowing bubbles can teach us how to keep our airways healthy, and it encourages our fine motor skills and also growth to scientific exploration. And also it will help our students discover, and I use these bubble shows in classrooms, science exhibitions. Resource persons for many schools in conducting bubble shows made me and my students to explore the physics concepts. More than 2 lakh students learned the science concept using the bubble. These are the processes while involving in bubbles, such as observation, experimentation, investigation, and discovery skills simply by studying the bubbles. Objectives: to develop help observational skill, learn science concepts in a fun and interesting way, to make a bubble and understand its structure, to explore and demonstrate various physics concepts such as surface tension, mixture, viscosity, friction, air pressure, force, etc. My hypothesis is that the design solution will make better bubble to teach the physics concepts than the ordinary soap solution. Materials I used are plastic tray measuring cups. These are the materials I used. A pre-test was conducted among 200 students from class 5 to 8 before starting the experimental study. The procedure I used is, I tried to make the bubble solution. So I decided to take 3 liters of water with 275 ml of dishwash liquid and added 3 ml of glycerin in it for and I stir it well and keep it aside for 24 to 48 hours. After 48 hours, it's ready for use. And I used straws to make shapes such as square, rectangle, triangle, like many shapes to explore the physics concepts. What I did is I dipped the square-shaped straw frame inside the bubble solution and form a bubble by blowing or waving it in hand, and asked the students to explore the bubbles to study the physics concepts. I dipped the square straw-shaped frame inside the bubble solution and formed a bubble, and asked the students to observe the bubble and ask the following questions to explore the physics concepts. I dipped the bubble in the solution frame and asked, what is the shape of the bubble? What causes the bubbles to form? Why do bubbles pop? Why do bubbles stick together? What is elasticity, like that? I asked many questions by exploring the bubbles, by giving the straw frames to the students and make them to dip in the soap solution and explore it by observing and asking many questions among to them. Then, for example, I dipped the straw frame inside the bubble solution and take it aside and showed the frame to the students and asked, what are the colors which form inside the bubble frame? They replied that many colors are forming in the frame, like rainbow colors. What is the reason for that, I asked. Such that I conducted many experiments and blown the bubbles and made the students to explore the bubbles. And the color of light, what is the color of light, we can explain using through this bubble frame.
Sir, please conclude.
Yes, sir.
Last 1 minute only.
Lot of concepts like viscosity, surface tension, air pressure, temperature, heat, like that we can ask many questions by using this bubble. A post-test was conducted using the above questions from the pre-test and the results were recorded. These are the results I found. During the pre-test, very little students only answered. After exploring with the bubbles, many students answered the concept of physics, such as elasticity, surface tension, temperature, why the bubbles pop, why the bubbles stick together, like that. They answered very quickly. And this is the conclusion I would like to conclude. While doing the experiments to learn physics through bubbles, engaged themselves the experiments voluntarily, understood the concepts easily and in a fun way. During the pre-test, if you only answered all the questions, they felt that terms were very difficult to explore the physics concepts such as surface tension, like that they found very difficult. After the bubble show and the students explored themselves playing with bubbles, they learned the physics concepts in a fun and interesting way and answered all the questions. The students went home, played with soap bubbles, experimented and shared the videos to our school teachers and all the other students. Thank you.
Thank you. Sir, is there any question? Okay. So friends, in this second session, which was started by the keynote address of Professor Ghosh Saab, we have started this session, and this session is now we are concluding. I request Dr. Seema Rajput and Dr. Ritu Sharma, who has done the work as rapporteur. So I request Dr. Seema Rajput to just briefly present within 2 minutes.
Thank you so much, sir.
तारिक जी,
yes sir.
बाद में presentation कराना, please invite करो इस speaker को.
Okay.
नहीं तो आपके presentation नहीं हो पाएंगे पेपर.
Okay sir. Okay. Now we are just handing over the session to next chairperson, Professor Ayushman Goswami ji, head DE, and co-chairperson Dr. Ramnivas sir, Dr. A.K. Arya sir, or Dr. Sneha Sudha madam, and rapporteur for that particular session is Dr. Uzma Rafi and Madam Tanu Kumari. Anandji?
Dhanyavad, Dr. Parekh. I hope Goswami sir, Professor Goswami, are you here? I take this opportunity to interact with you. Honorable Principal, Sir, Professor S.V. Sharma, esteemed participants, our keynote of the session, Professor H.C. Jain and Professor Shashi Prabha. My colleagues, Dr. Aishwan Goswami, Dr. Ram Niwasji, Dr. Snehi Sudha, and the reporters, Dr. Ujma and Madam Tanu Kumari. I welcome you all in this session. We are exactly 1 hour late than our scheduled time. So it's a request to all of you to please be at your scheduled time. And first we will have the 2 keynote sessions, and after that we will have the presentation, paper presentation from the participants. And for the today's keynote, I invite Professor H.C. Jain. He will deliver a session on changing priorities in physics education. When it comes to physics or the physics education, there is always a name that is Professor H.C. Jain, and I'm lucky enough to introduce Professor H.C. Jain. Professor H.C. Jain is retired as a principal of our institute, Regional Institute of Education, Ajmer. He has worked extensively in the area of physics education. He has many reputed publications in refereed journals. He has more than 100 research publications in the Journal of International and National Repute. He is actively engaged in the extension activities as well as in the developmental work. We are lucky enough to work with him, and he's a nice person. We have heard him many times, and without wasting so much time, I invite Professor H.C. Jain to deliver his session on, that is, the priorities, changing priorities in physics education. It's a simple, I like to say that the session will be of 20 minutes. So it's a request, sir, to finish it by 4:50. Please, sir. 3:50. Please, sir. Please, sir, you are invited. Professor H.C. Jain.
आनंद
जी सर,
शायद जैन साहब अभी जुड़ रहे हैं, तो अगर प्रोफेसर शशि प्रभा जी कनेक्टेड हैं तो वी कैन रिक्वेस्ट सर.
शशि प्रभा मैडम, प्रोफेसर शशि प्रभा.
Hello, good afternoon everybody.
Thank you madam. Please आपका एक heartily welcome to you. And let me introduce our keynote speaker, Professor Shashi Prabha, and she will deliver a keynote session on using augmented reality in teaching learning of ray optics. This is the area nowadays which is required a lot of attention. Equally, Professor Shashi Prabha don't need an introduction. She has worked a lot in physics and physics education. Professor Shashi Prabha joined NCERT in our institute, and presently she is working as a professor of physics in NCERT. Nowadays she is working with the CIT, and she has worked in number of research projects, developmental activities and extension activities. and she has excellent command of physics and physics, how the physics can be taught. She has developed many educational material, e-content, and she is actively engaged in physics teaching and physics learning. So, madam, I invite you for this session. And as I have said, the session will be of 20 minutes. So it's 3:30. We'll request you to finish it by 3:50. Please, ma'am, you're most welcome.
Thank you very much for inviting me as a keynote speaker. Dear Professor S.V. Sharma, my colleagues, and dear participants, I'm very happy to interact with you all. And I feel privileged to share this virtual platform with experts of physics, like in the morning, we listen. So I am going to present using augmented reality in teaching learning of physics. So just 1 minute, I want to share a screen. Yes, is it visible?
Yes, madam. It is visible. Please go ahead.
Very good, very good. So we know that NEP 2020 emphasized on the importance of leveraging technology for teaching learning of all subjects and at all levels. And also it envisions integrating content, pedagogy, and technology in teaching learning of all subjects. And it envisions development of a digital repository and development of AR/VR material also. So in this context, we have developed some AR contents in science in CIT. And I am going to discuss about the pedagogy and technology of ray optics, how it can be implemented. So it is not moving. Yes. So the content creation, digital repository, and dissemination, all these are envisioned by our national education of national policy of education. So augmented reality, what is augmented reality? Because many times what happens that AR and AI, these are the different things. So earlier I listened a good talk of AI, this is AR. So it is a view of the real and physical world. And it helps in concretization of the abstract concept by mixing the digital world with the real world. And here it is overlaid. What is overlaid? Graphic, music, animation, GPS marker, log, etc. to the virtual, to the real environment. So it provides an immersive and interactive experiences that overlay, document, image, audio, video, graphics in the physical world. So we know that in physics, there are many concepts, abstract concepts where students find difficulty, and ray optics is one of that area. So in ray optics, students actually, they find difficulty in drawing the ray diagram. And if some alternative conceptions are held by students, then that can impede their learning. So it is very, very important to address their learning needs. And previous studies have shown that ray diagram actually helps in conceptual understanding of ray optics, but at the same time, ray optics, if ray diagram is not learned properly, then it can generate misconception, alternative conceptions also. So it is very, very important to address those needs here. How it is done? We have developed a mobile app, e-Pathshala AR app that can be downloaded from the Google Play Store. So a mobile is kept over the textbook, over the figure. So when the app opens and it starts audio and video. So just 1 minute, I would like to just show how does it work. Is the screen now visible? Different screen? Is now different screen visible now?
No, ma'am.
Madam, we are not able to see. Just we can see only the links.
Okay, just from the links itself, I will try to open. Just bear with me. So, is it now visible?
No, ma'am.
Only the links, ma'am.
Oh, please.
Madam, these are available online?
Yes. Is it now visible?
Ma'am. Now it is visible. Please.
Yes. Just I want to show it, then we can discuss over it. So,
click on the continue button to continue.
So this
ray
is
of light. A ray is a path of a light wave represented by a line with an arrow. The arrow indicates the direction in which light is traveling. Beam of light. A bundle of rays of light is called a beam of light.
Now I will
Center
move
of
faster.
curvature. It is not concave mirror. Click on the highlighted button to make a ray incident parallel to the principal axis.
It is audible and visible to all of you?
Drag the slide image.
हाँ जी हाँ मैडम आवाज भी आ रही है दिखाई भी दे रहा है.
This on a concave mirror. After reflection and invert to continue is equal to the angle mirror. Click on the highlighted button to make a ray incident parallel to the principal mirror. After convex mirror, click on the convection 1. The normal to the mirror at the to continue. Click on the continue a parallel to the principal axis. After reflection will pass through the principal focus in the case of a concave mirror, or appears to diverge from the principal focus in the case of a convex mirror.
Yes. Now it is visible. The PPT is visible.
Yes, madam. PPT is visible.
Okay. Thank you. Yes. These augmented reality materials have been made on various subjects on ray optics also, and here why we are emphasizing on the ray optics on the basis of our observation and our whatever literature we have found that ray optics is students they have many misconception here. So their misconception needs to be addressed, but what we want to emphasize that let us first see the benefit of augmented reality in teaching learning. The number one is the visualization, that when students observe and see the abstract concept in real life situation, in 3D simulation situation, they feel like part of the system and they can understand well. So this is also based on the Dale's cones of experiences, all of us we know, and there is a feeling of immersiveness because there is a provision of controlling the screen, like they can move the lenses in 3D in backward or forward direction, and also they are kept engaged in teaching learning because they can see that how rays are being reflected or refracted, and collaboration is also there, like they can interact with the virtual world, and also they can interact with the real world observing this. And if pedagogy is planned properly, then students can interact with their peers as well as teacher. It is self-paced. It caters the learning need of all students, whether they are slow learner, fast learner. They can move forward, backward. They can review their this AR material. They can reflect on the concept what they have learned, and it provides a flexible environment. They can learn this, they can watch, they can see this thing anytime, anywhere, and therefore it stimulates students' motivation to learn more deeply, and therefore it presents abstract concept as visible and audible material. So here it is important for the teachers that it is important that how technology is used by integrating with the pedagogy and the content. So just letting students to watch this AR material on their own might not lead their conceptual understanding. So monitoring their own learning needs to be facilitated. For that, some leading questions should be provided. Obviously, if lots of questions are given by the teacher, that will be more structured teaching learning. So that would not lead much understanding. But in the beginning, some questions may be developed based on the learning needs, styles, and local context of the student. And also, teachers should ensure that students do not work as a passive learner. So encourage them to ask questions. What did they learn? What else they want to know? So all these things should be encouraged, and more collaborative work should be done. Like if one student is putting his or her mobile over the textbook and the audio is coming, then it is obvious that all the students will do, then there will be much noise in the class. So how it should be implemented in real teaching learning situation, that needs to be decided. So if it is a group work, then all the concept needs to be discussed. That what is the need of ray optic, drawing ray diagram? Is it it is a theoretical thing, or it actually one line passes? What is the need of showing arrow? What is the direction of rays of light after reflection and reflection? There many questions can be asked. And after that, it is also important that students should be encouraged to draw the ray diagram and explain the phenomenon of reflection through a spherical mirror, or if they are doing on spherical lenses, and the relevant concept. So how can we know that they are learning well? So if they are able to apply their learning in real life situation to solve many problems, then we can conclude that they are understanding the concept well. So some leading questions have been suggested, like Observe the AR content and give the name of F, R, and P, like principal focus, radius of curvature, pole of the mirror. Can you observe real image of an object placed at any position on the principal axis of the concave mirror? What is the direction of deflection of a ray passing through the center of curvature of the concave mirror? Similarly, a number of questions have been can be planned. This is just a suggestive. So similarly, many more questions can be planned. A ray is incident obliquely to the principal axis towards P on the concave mirror. Is it reflected obliquely? What type of mirror is used to produce image that is upright and reduced in size? So from the research studies, previous research studies, some alternative conceptions have been collected that when a ray passes through two different media, a straight line of a light ray can be used at the junction interface. It is their understanding. And many times students, they get confused that when ray will reflect, when it will refract, and how ray diagram can be drawn using only 2 rays only or 3 rays only 3 rays exist. So they fail to understand that infinite number of rays can be drawn from the object. And also what is the need of drawing arrow? So many times they forget to draw the arrow. Image can be seen on the screen only and nowhere else. Convex lens show a object is smaller. So all these are their misconception. So looking at the misconception, that can be taken as the springboard for starting the AR integrated teaching learning. In reflection also, some misconceptions are there, like plane mirror can produce an erect image on the screen. Light stays on mirror during reflection. It is not necessary to make arrow on the rays of to show diagram. We had also conducted research on this aspect, and we have collected the data from our studies also. So one-to-one, whatever is existing, so that should be in dialogue form, discussion mode. So and student can go to the AR content many times. So it can be given as the assignment also, their group discussion also, and the AR content teaching learning can be used as a blended mode of learning. Like student can first go through the AR content, then they can come to the class. And AR content is based on the basic theories, a basic paradigm of teaching learning, like constructivist approach. Student like they construct new knowledge by relating with their existing knowledge. And also it is said that it is based on the behaviorist approach also, like stimulus response theory. So whatever theory is used, whatever paradigm philosophy is used, technology provides an extra edge to the teaching learning process, to the pedagogy. So with the help of these integrated technology, integrated teaching learning, now conceptual change model can happen. Like here, what can happen? They become aware of their preconception, expose their belief. Okay, I think like this. Confront their belief by testing and discussing them, resolve conflict, and extend the concept to make connection with their everyday life situation. So they can go beyond pursuing additional question and problem of their choice, apply in their everyday life situation. So this is Stephen's conceptual change model. So we can use that also. So here now, what is the gist of my presentation? It is that technology in education is a journey. It is not a destination. It is not the end product. And here, this year we had developed these material. Obviously, the development was also based on the process of research. Now, further research work is planned to study effectiveness of AR in teaching learning of science. And these materials, some of the materials have been uploaded on Diksha platform. And I suggest our participants, practicing teacher and teacher educator, they can also take research study on individual AR content. and pedagogy needs to be evolving to make physics education more inquiry based, discussion based, and having flexibility. And of course, the teaching learning needs to become more enjoyable. And since in the present generation they are more techno savvy, and they find interest in technical aspect, because based on educational technology, other research program have been taken, and studies have been taken to various school and teachers also, and we have found that students are very much interested in a technological aspect of teaching learning. So augmented reality has the potential to take physics education to a higher level and bring excellence if content, pedagogy, and technology are seamlessly and suitably integrated with each other. So I would like to emphasize again that it is very, very important to seamlessly infuse, integrate, interweave technology and pedagogy and content, so that conceptual understanding of students can take place. In the name of technology, we cannot give the devices to students that learn yourself. So inquiry based teaching learning should be emphasized, discussion based, and as planned, as envisioned in NEP 2020, that our students should be able to develop 4 C's of 21st century skills, that is creativity, critical thinking, communication, and collaboration. So communication is very important. How to represent the concept of science using scientific convention, using proper diagram, symbol, etc. That is also very, very important. So thank you very much. And if there is any question, you are most welcome.
Thank you, madam, for a wonderful research of the information you have been provided to us. Really, augmented reality is very much necessary for understanding of the certain concepts which requires the imagination. So we'll be happy. Still, we have 1 and 2 minutes. If the participants like to discuss anything or clarify the doubts from our experts, we'll be happy. Please, anybody? Professor Sashi Prabha is working as a professor in NCERT, and if you have any query, you can ask directly to Madam also, or you can associate yourself from the WhatsApp group we have, so we can directly put your query before Madam. So thank you, Madam, for being with us in this conference, and thanks a lot.
Thank you very much. Thank you all.
Can I ask a question, please?
Please, ma'am.
Ma'am, I would just like to ask that you said regarding an app from where we can access these things. So can you please name once again the app?
It is ePathshala AR app, can be downloaded from Google Play Store. And these many videos, as and when it is being finalized, it is uploaded on Diksha portal on the relevant chapter of the textbook. So if this is of class 10th of a light chapter, then you need to open light chapter on the Diksha platform class 10th, and there you will find some connection.
Ma'am, just another doubt. Is there any form of app or any particular software available where we can ourselves make use of augmented reality and make these concepts concretizing for the students?
So very encouraging question you have asked. Of course, there are software available, but we work with a technical team, because here coding is required, programming is required, storyboarding is required. So we develop a storyboard, and we just guide and instruct the technical team to develop whatever content we want. So the technical team is a huge team, and each member, they are working on other things, each and other things. So it is I came to know that it is not feasible to design all these things by one person. That is what I came to know, because we are working in the area of physics more, and technology wise, I came to know that we need a team of technical person to develop this. Of course, you can learn some program.
True. Thank you so much, ma'am. Thank you.
Thank you. Thank you.
Thank you, ma'am. Professor H.C. Jain sir is with us. Jain sir, are you with us? If Jain sir is not with us, we can take the keynote address after the presentation of the participants. And without wasting our time, can we proceed for the presentation of the participants?
Hello.
Today's
Hello.
Today's session. Hello.
जैन सर
जी
ज्वाइन
सर.
कर रहे हैं आनंद जी हेलो
जी सर.
जैन
जी
सर
सर.
जुड़ गए हैं
अच्छा
सर हाँ
जैन
सर
सर
सुनाई दे रहे हैं हेलो
हाँ सर, आवाज आ रही है। जैन सर, आवाज आ रही है आपकी।
तो ये खत्म कर, ये तो लीव करें इसको
हाँ
no sir, please.
ठीक है। प्रोफेसर शशि प्रभा मैडम, जरा आप अपना स्क्रीन शेयर जो है ना, उसे स्टॉप कर दीजिए। शशि प्रभा मैडम,
शशि प्रभा मैडम, अपना आप स्क्रीन शेयर बंद कर दीजिए।
एक मिनट, आई एम ट्राइंग।
at the top there.
Technical
at the top,
team,
there is green.
please. Technical team, please.
Oh, at the top there is.
Stop now.
Yeah, there is stop.
नहीं, अभी स्क्रीन शेयर स्टॉप नहीं हुआ है मैडम।
At the top. Leave the screen.
राजेश शर्मा जी देखिए वहां से।
I am leaving the meeting, then that will be easier. I will join again.
ठीक है।
It's a matter of pleasure for us to have Professor H.C. Jain. Sir, I welcome you in this session, and I have already introduced you, but again I'm introducing you to the participants. Professor H.C. Jain is not a new person as far as physics and physics education is concerned. He is a renowned physics educator. Professor H.C. Jain retired as a principal from a regional institute of education. He worked extensively in the area of physics education, and he has published more than 100 research publications in a refereed journal of international and national review. He is actively engaged in extension activities, research, and in the developmental work. And it's a matter of pleasure for me to work with him and learn with him many things. And it's always been a pleasure to listen him. Sir, it's a honor for us to listen to you. Please, you are welcome for the session. And since the time is less, so 20 minutes are allocated as a scheduled time. So please, I welcome you.
Are you able to listen to me?
Yes, sir. We can listen to you, and we can see your presentation also. Please, sir.
Okay, shall I start?
Yes, sir. Please.
Okay. Now, as you know, my topic is changing priorities in physics education. A Nobel laureate, David A. Gross, he said, physics is the king of all sciences. Now, it was known as natural philosophy before 19th century. It has the interrelationship with other subjects, for example, physics, chemistry, and biology. But it has a deep relationship with the queen of the subject, that is mathematics. Now, physics education has been important at all the levels, and that's why it has been amalgamated at different levels. At primary, we talk of environmental education. At upper primary, we talk of general science. At secondary, we talk of, say, integrated science. Then at +2 level, we take it as a discipline. At lower levels, the topics of physics have been amalgamated. Now, there is need of physics to teach it at all levels. Why? Because it has got technological applications and it improves the quality of life. So that's why it is very much important to learn physics. In the morning, you also heard Professor Ghatak. He also said that physics probably should be taught to everybody. Now, there has been impact on physics education of different subjects because it is interdisciplinary, it is multidisciplinary, it is transdisciplinary. Interdisciplinary means that many themes can be combined within physics. Multidisciplinary means that other disciplines like chemistry, biology, and other subjects can be combined. Transdisciplinary means that it should be problem-based, it should be critical thinking, and so on. Now, the questions are whether any other subject has the impact. Now, of late, even psychology has had a lot of impact on physics education. So the question comes, what physics we should teach, how we should teach, when we should teach, and why we should teach physics. Again, I repeat, there are 4 questions: what physics we should teach, how we should teach, when we should teach, and why we should teach physics. Teaching of physics is unquestionable. As I said, that it has an impact on technology. It improves the quality of life. Now, there was a time of Aristotle's views. We talked of Gallium discoveries. We talked of Newtonian mechanics. And then era came, we talked of discovery of electron. Then came Einstein's theory of relativity. Then came nuclear physics. Then came quantum theory. Then came statistical physics. Then came particle physics, solid state physics, space physics, so on and so forth. So in this way, you see that as far as the content part of physics is concerned, it has been changing quite fast. Frontiers of physics have been expanding very, very fast. But I am going to talk much more about teaching of physics, not much of that of content. Why? The question is, how much we can teach? How much content we can teach? It is impossible to teach all the content of physics. to the students. It is very difficult. So there should be something else, that is pedagogy. If we prepare the learners in such a way that they become independent learners, then they will themselves learn different type of content. Now, as far as the physics is concerned, radical paradigm in pedagogy came in 1957. Why it came? Because before that, physics was being taught. It was being either transmitted, not taught. It was being transmitted as definitions, rules, laws, principles, formulae, and theories. Before 1957, we will ask what are Newton's laws. We will ask what is Huygens theory. We will ask that, okay, give the definition of force. This was happening. But on October 4, 1957, Sputnik was launched by USSR. Americans got surprised. They thought, what was wrong with their educational system? And what was wrong with their physics education in particular? And therefore, they started thinking. So there was an onset of physics education for inquiry. So the inquiry perspectives started from 1957. A book came in late 50s, rather early 60s, by Eric Rogers, Physics for Inquiring Mind. I don't know how many of you have read it. Physics for Inquiring Mind. Also, a number of projects were undertaken in USA. PhD in USA, Nuffield in UK, HPP in USA, at school level. These projects are designed for school level. Then Berkeley series and Feynman lectures. These were designed for graduate level, for college level students. So Americans started with these projects. As far as PSSC was concerned, I will only talk in brief about these projects. Physics was presented as a physical model. That is, you do a certain experiment, make a model, do another experiment after this model is devised, make another model, and go on. So you have to create the idea that physics is always tentative. There is nothing like absolute. There is no absolute truth. Now, I will give you one example. You must have learned light travels in a straight line. Rectilinear. This is rectilinear propagation of light. When you come to interference, you can't explain with rectilinear propagation of light. You come to wave theory. When you come to polarization, then you cannot explain unless you consider the transverse nature of light. Now, after that, you see that you go for the electromagnetic theory, so on and so forth. So see, this is a model approach. Experiments are conducted and the model approach was adopted. There was novelty in experiments. I don't know how many of you have done PSSC experiments. Find out the thickness of the paper. Find out the mass of the electron. Determine magnetic field in fundamental units, and so on. Ripple time. There's so many experiments, very exciting experiments. Then as far as the field program was concerned, this represents a fabric of knowledge. Fabric of knowledge means that all the concepts should be interwoven. It should not happen that there is one thing, there is another thing, there is a third thing, and so on. These should be interwoven. For example, if we are talking of force connected with energy, if we are talking of energy, then talk of heat energy, talk of light energy. And this way you can connect. Now, if you are talking of energy, then talk of work. So in this way, make a fabric of knowledge. And for all those, you make the inquiry. That is, the inquiry approach was adopted by PSSC approach, by Nuffield approach. Then in Nuffield, there are questions something like this. You know the formula, S is equal to UT plus half AT squared. Now, why this factor half is there? Why this factor half is there? A very popular relation. What does it mean? What does UT means? What does AT squared mean? And how these quantities are related with other quantities. So in this way, you see, make inquiry through experiment, make inquiry through thinking. I will come to thinking, about thinking aspect later. Another project was designed, that was HPP, Harvard Project Physics. Now this project had the quality that it was a historical approach of how the different concepts have evolved with time. So in this way, that HPP is a historical approach. That in this year, this was devised, then thereafter this happened, and so on and so forth. Then coming to Berkeley series, now this is for graduate level. And in the morning, Professor Ghatak was talking too much about Feynman lectures. If you see, Feynman lectures are unique lectures in physics. These are published in 60s. Remember, all these projects, PSSC, Nuffield, HPP, Berkeley, all these projects and Feynman lectures, these are published in 60s. The Sputnik was launched in 57. The steps were taken, and thereafter, all these steps were taken by USA, and that's why all these projects were designed. Now, at the same time, educationists, Bloom came, and Bloom gave the taxonomy of objectives on variety of cognitive skills. He said that it is not sufficient to confine your knowledge to recall, recognition, or to simpler, you can say, skills, inquiry skills. You should go to higher order skills. That is, you should know how you can apply your knowledge of concepts, conceptual understanding. Then you should go for analysis, you should go for synthesis, you should go for creativity, you should go for critical thinking, you should go for imagination. You see that physics is developed not through only conceptual understanding. It comes through imagination, it comes through creativity, it comes through intuition, and so on. So focus of physics in 60s and 70s shifted to development of process skills. At the same time, the process also included key operations in physics against transmission of knowledge. content and rote memorization. As I said earlier, that before 57, content was transmitted, students memorized, and they recalled. Now the concept was that we should develop process skills. And also they should be trained in key operations in physics. Now, I will take both of them. What do you mean by process skill? Now, whenever you do any activity, some actions, some activities, some experience goes in your mind. I repeat, whenever you do any activity, then some activity, some experience, something goes in your mind. Now, what is going in your mind? That is the process skill. Now, this is in terms of knowledge. This is in terms of conceptual understanding. This is in terms of application of physics concepts. This is in terms of analysis. This in terms of synthesis, creativity, and all these process skills have also been subdivided. Now, what do you mean by key operations? Now, as far as key operations are concerned, it means the operations which a scientist adopts, which the physicists use. Now, what a physicist does? What a physicist does? As Einstein said, that whenever I think, I make a mental structure in my mind. I make certain diagrams in my mind. Prior to that, I review the literature, and then I make certain thing in my mind. It may be in the form of diagrams. This is what Einstein said. I make some structures, and then when these structures come, I jot down. And when I note down, then I try to investigate that how I can proceed further. So in this way, focus of physics education shifted in 1960s and 70s to development of process skills and key operations. A lot of instructional materials were prepared by so many agencies, including NCERT. Now, so approach was didactic instead of didactic. Didactic approach means teacher-centered. Dialectic approach means learner-centered. So when you make these materials, when you make these activities, then this is dialectic approach. Right? Now, it was fashionable then to develop projects for integrated science. For integrated science. It was fashionable to develop projects after 70s. It was fashionable to develop projects for integrated science. A number of methods were used, and you know probably about this heuristic, project, discovery, guided discovery, besides investigating, inductive, deductive, where you go from specific to general, and here you go from general to specific, problem solving, scientific method, where you make identify the problem, then make the hypothesis, then procedure, then test the hypothesis, and so on and so forth. Now, so you see, so the emphasis was on, this is not experimental, this is experiential. This is wrongly written here. So this is experiential learning through hands-on activities, skills, and thinking processes. And we should go for reasoning, creativity, problem solving using physics content. And we should develop process skills not only through theory, but through practicals also. Because in practicals also, this is also possible. Now, so now another event came. You see that before 1957, if there was emphasis on content, so how persons used to define physics? They used to say that it is a conglomeration of, say, concepts, conglomeration of content, a number of, say, laws, a number of facts, a number of definitions. Now, what the people started saying, that physics is nothing, it is a process. Physics is nothing, but it is a process. So that the priority became that it is, physics is a process, not content. Now, there was a difficulty. The content persons, they said that as far as your emphasis on process skill is concerned, it is all right. But this should not be overemphasized. Why? Because there are two things. There are two difficulties. One, activities become rituals. Science is not doing. Science is conceptual understanding. Physics is conceptual understanding. Physics is making use of the concepts for application and so on. So, overemphasis on process skills, which was based on activities, was criticized that it is not developing concepts. Rather, activities are becoming rituals. There was another difficulty because you see that as far as process skills are concerned, for example, take observation. This is not unique. Now, if you are observing a meter scale and you are observing through microscope, in both, observation is not of the same category. Observing a scale and observing through a microscope, now see, both of them require different talent. Both of them require different things. So to say that we have developed the process skill of observation, it is not correct. Similarly, you can talk of other processes. So overemphasis on process skills was criticized. So another idea came that integrate process skills with conceptual knowledge. Integrate process skills with conceptual knowledge. Now, if you are doing it, so a number of studies were conducted. I talked about 70s. So now a number of studies were conducted right from 70s. But more studies have been conducted after 90 or after even 2000. And a number of studies about alternate frameworks. That is what the students have ideas about a certain concept. What are their preconceptions? What are their misconceptions? What are their views? What are their informal ideas? So right from 70, now in 70, a paper came from Ryder. She is no more, from UK. And she, at the same time, Piaget had emphasized that the process of learning involves that what the students know. Or prior to introducing a concept, what the students know, it is very much important. It was also said by Ausubel. Ausubel said that the prior knowledge should work as an anchor, as a springboard for developing the further knowledge. So this idea generated in 70s, but it remained silent in 70s. And in 80s and in 90s, the idea why this idea was there, a number of papers have come regarding that. I have also published so many publications in that period. Now, to understand these alternate concepts, we adopt one model, probably you might be knowing, that is a very popular model that is known as 5E model. 5E model means engage, explore, explain, then elaborate, evaluate. Are you repeating? That to know the learner's concepts, prior concepts, in general we adopt 5E model. It is engage, that engage the student in some activity or through discussion, etc., so that he is involved, right? His mind is involved. He starts thinking. Explore, then he starts exploring. Then explain, then let him explain. Ask him to elaborate. Then ask him that, okay, now you evaluate, can you explain some other things? So this is a very popular model. It has been adopted by so many persons. There was another model, that is concept mapping. Now in this concept mapping, what we do, there is an ordinate concept, then there are subordinate concepts. You jot down what is the main concept. Then you note down what are these subordinate concepts. Jot down. Put the main concept in the center and then provide the linkages, that what linkage can be provided with another concept. So this technique has also been adopted. Then another technique is Venn diagrams, where you see that what we do, that we take circles. For example, circles, that you take 3 circles. No, sorry, you take 2 circles. Now 2 circles are intermingling. Now there is some area where they are overlapping and there is some area where they are not overlapping.
जैन साहब, मैं सर थोड़ा सा आपको क्षमा चाहूंगा, आपका सुनने में ऐसा लग रहा है सर हम आपको सुनते जाएं, लेकिन थोड़ा सा टाइम की शॉर्टेज है सर, अगर आप समय पे कर देंगे जी.
Okay.
जी, thank you sir, thank you.
Okay, so when the area where these things are overlapping, okay, now there you can write down what things are overlapping. For example, in series and parallel circuit, what is common, what is not common. Now these are the views from 1970, but emphasis has come from 1990s. What is learners' mind? Learners construct their own meaning. Construct of meaning is an active and content process. Learning may result in conceptual change. The construction of may not always lead to belief. Learners have ultimate responsibility. Constructed meanings are shared. Then, after constructivism, this was also criticized. This has been criticized. Now, after 2000, rather I will say in 2005 or 6, epistemology of physics has come. And this speaks about beyond constructivism. Because there is a difference how the knowledge is created and how the knowledge is learned. There is a difference between the two. As far as constructivism is concerned, it takes the two things together, while epistemology says that these are different. So this way, now, there was another decade, another idea in 1980, and this was that physics for inquiry, this is what we are doing. But there are technological applications. So you see that this triangle represents physics for inquiry. Rectangle explains that technological aspects, because this is very much necessary for benefit of human beings. Then this is for physics for citizen. Circle. Physics for citizen means that inculcation of values, attitudes, and making a good citizen. So you see, then in 1980s, this idea had also generated, and this idea is known as STS perspective, science, technology, society perspectives. So physics for action, physics for inquiry, first physics for action, then physics for citizen. Now you see that thereafter, now what should be situation now? I am coming to the final point, that what should be the situation now? Physics should be treated as multidisciplinary, interdisciplinary, and transdisciplinary. There should be holistic approach. Physics curriculum should be contemporary. Computer-aided instruction, it has also gained acceptance. Emphasis on learning outcomes based on critical thinking, creativity, analytical approach, and value education. But here I will narrate only one or two lines. What quality of physics education we expect? You all know Thomson discovered electron. You know who discovered proton? Rutherford. In 1897, probably, Thomson discovered electron. In 1913, probably, maybe here something is different. Rutherford discovered student. Rutherford discovered proton. Rutherford was a student of Thomson. And in 30s, in 1933 or 35, neutron was discovered. By whom? Chadwick. Who was Chadwick? Chadwick was the student of Rutherford. So what of physics education do we expect? We expect the teacher-taught lessons should be of this type. Thomson, Rutherford, Chadwick. Remember, this type of teacher-taught relationship we expect. Now, there are some other things also, there are some other approaches also, some model approaches have also been adopted. About Piaget's model, I have talked. There is analogical model where analogies are used in order to explain the things. Generative model where you depend on orientation, elicitation. Now these are the recent techniques. Analogical model, generative model, where you do activity, interaction, then assessment and field. These are the different points which are used in generative model. And then collaborative learning, where you involve 2 or more individuals. Then speed learning, breaking a long course into several modules. Flipped classroom, where this is a sort of blended learning, where classroom activities and homework, these are reversed. Gamification, this is another approach which is being adopted. Crossover learning, self-learning, and so on and so on. So these are the recent techniques which have been happening, you can say right now. So you see that to summarize, I will say that physics education should be the synergy. Physics education should be the synergy of conceptual understanding, application of concepts, development of conceptual understanding, development of process skills, development of higher order mental process skills, development of application of conceptual understanding, and then development of values, attitudes, scientific temper, so on and so forth, so that you can be a good citizen. You see that you cannot do anything unless you are not a good citizen. Thanks. I have switched over to so many aspects very swiftly because of the paucity of time. I'm sorry.
Right, sir. Right. Thank you, sir. Thanks a lot. It was really wonderful to listen you. Your session was very informative and some unique things like the Thompson, Rutherford, and Chadwick. It was really wonderful. Very quickly, we can take a few queries from our participants. If you have any query and you want to interact with Professor H.C. Jain, you're welcome. Please, anybody. So many of participants, because of the time, they are giving their responses on the chat box. Recently, we have received one of the our own students, Neetu Agarwal. She has also given you regards, sir. So thanks a lot, Professor H.C. Jain, sir. It was thank you for such a wonderful session.
Thank you.
Next.
सर जैन सर स्क्रीन से स्टॉप कर दीजिए.
Now we can take the presentation from our participants. This is theme third, and it is the experiments in physics, past practices, and emerging trends. And we have our reporters, Dr. Ujma Rafi and Ms. Tanu Kumari. And for the first session, I'd like to call Shri Pyare Lal ji. Pyare Lal ji?
Yes, sir.
So only because of the time, only 4 minutes, or we can say 5 minutes are given for the discussion. So please stick to the timeline, and you're welcome. You can share your screen and start presentation. Please,
Okay, sir.
Pyare Lal ji.
Yes, sir. Yes. Is my slide visible, sir? Okay, sir. Thank you. Good evening, everybody. This is Dr. Pyare, University of Rajasthan. Today, I am going to present a paper entitled "An Advanced Study on Ultraviolet Gain Characteristics of Aluminum Gallium Nitride in Nanotechnology." This presentation's aim has been to investigate an advanced study on ultraviolet gain characteristics of advanced material aluminum gallium nitride based nanostructure for various applications of verification and serializations for the society in emerging nanotechnology and nanophysics. This is layout of presentation, introduction, theoretical details, results and discussion, conclusions and references. First of all, we define introduction. Introduction is the junction between two additional band gap materials, and hetero structure is the combination of multiple hetero junction.
डॉक्टर प्यारेलाल जी.
Yes, sir.
आपसे एक निवेदन है कि ये इंट्रोडक्शन और इन सब को एस्केप करते हुए ना, जो आपका सेंट्रल थीम है, सेंट्रल आइडिया है पेपर का, वहां पे जाके और फाइंडिंग्स और रिसर्च जो आपका रिजल्ट है वो शेयर करें, तो वो हम सभी के लिए, आपके लिए बहुत ही यूजफुल रहेगा सर.
This is definition of light. L stands for linear propagation, I stands for invisible, G stands for group of Vigor, S stands for heat, and T stands for transverse. The definition of light is existed in letters of light. L stands for linear propagation. Light is the always propagate in linear path, and I stands for light is the itself invisible, but objects are visible by light. And light is the group of 7 colors: violet, indigo, blue, green, yellow, orange, and red. And light is the heat form or energy form. And T stands for transverse electromagnetic wave. Light is the transverse electromagnetic wave whose wavelength is 38 nanometer to 78 nanometer. Now, result and discussions. This figure represents the graphical behaviors of ultraviolet gain with lasing type wavelength of ultraviolet photon and peak model gain type ultraviolet gain with density of carriers for gallium nitride. In this figure, the ultraviolet gain per centimeter with wavelength of ultraviolet photon nanometer represented by the left axis and bottom x-axis. Next, the model UV gain per centimeter with carrier density per centimeter represented by the right axis and top x-axis. It is clear by the ultraviolet gain spectra that the higher value of ultraviolet gain light gain is achieved at the wavelength of 254 nanometer. This wavelength has been extensively utilized in the applications of purification and distillation of air, water, surfaces, etc. So this type wavelength ultraviolet light has been more effectively to eliminate the various types of bacteria, viruses, and very harmful contaminants without any loss. And this figure represents the variations in performance of parameter of anticoagulant with density of carriers per centimeter cube and ultraviolet gain with current density per unit area for proposed nanostructure. And last conclusion, this presentation provides a substantial and critical contribution in the optimization of innovative study of a computational and investigation of ultraviolet gain light or gallium nitride. Under this analysis, the spectral performance of ultraviolet gain with wavelength and peak ultraviolet model gain with carrier density have been calculated. Under the results, the high value of ultraviolet gain has been achieved at the wavelength of 254 nanometer. The wavelength 254 nanometer has been more utilized in the applications of purification and distillation of air, water, and surfaces, etc. So this type wavelength ultraviolet light gain has been more effectively to eliminate the various types of bacteria, viruses, and very harmful contaminants without any loss and mineral of water. These are references. Thank you, sir.
Thank you, Pyarelal ji.
Thank you, sir.
If any queries or any questions are there, you're most welcome. Please. So thank you, sir. No queries there. Now I invite JJ Rushmitha, and JJ Rushmitha is there.
Yes, sir. I'm here.
That's good. And she will present her paper on synthesis of copper ferrite nanoparticles using co-precipitation method. Please, ma'am, you're most welcome.
Sir, I'm Smitha, research scholar from Women's Christian College in Tamil Nadu. I'm here to present about the synthesis of copper ferrite nanoparticles and the co-precipitation method. The research work is done under the guidance of Dr. S. Radhika and under the guidance of Dr. C.M. Padma. Sir, an exponential interest in nanoparticles from researchers and scientists have been waved freshly, not only because of its smaller size and structure, but also due to its significant advantage over technology and applications. In the range of nanoscale, nanoparticles exhibit several unique and incomparable chemical, physical, biological properties than the particles in the range of higher scales. Among the ferrite-based nanoparticles, copper ferrite has the most wide applications due to its potential. Based on the crystalline structure and physical properties.
Madam, please escape this part. Please escape this introduction part.
Okay, then I will explain about the synthesis. How to synthesis a copper ferrite nanoparticles. 1:2 mole ratio of copper chloride and ferrichloride were taken. At a stoichiometric quantity, the precursors were blended using distilled water in a magnetic stirrer. At constant temperature of 80 degrees Celsius was maintained. And then the precipitating agent was introduced drop by drop till the pH of the solution reaches 12. At this stage, slurry precipitate was formed, which was washed for about several times till the pH of the sample reaches 7. Then the precipitate was dried to obtain powder. Finally, the synthesis precipitate was annealed at 1000 degrees Celsius for about 5 hours. Again, the sample was crushed using mortar and pestle only, and the fine particles are obtained. To characterize the fine particle, I have used X-ray analysis. From the XRD analysis, it is clear that the observed particle is copper ferrite, as it is of the peak 34 to 36, and the crystalline size is calculated using the formula D is equal to K lambda divided by beta cos theta, where K is the shape factor and support 0.9, lambda is the wavelength of the instrument used 1.5406 Armstrong, and beta is the full width at half maximum, whereas theta is the angle of diffraction. And also, William Hall plot method is used to analyze the crystallite size of the sample. Finally, the copper-fed nanoparticles were synthesized successfully using co-precipitation method. This is a cost-effective method and also the easiest method among all chemical methods. X-ray diffractometer is used to characterize the crystal structure and synthesis nanoparticle. And the successfully synthesized nanoparticles were found to be 16.79 nanometer in range, which is a good range of comparable. Thank you, sir. Sir, am I audible?
Thank you. Yeah, thank you, Smitha. It was really a nice presentation. Any queries from the participants? Okay, just I have a query. Have you gone for the SAM and TAM of the nanoparticles you have synthesized, or have you utilized this in some reactions
Yes,
or some?
this is the initial stage of my work. I have sent it for UV DRS also. Some and TEM are in progress. EDX is also in progress, sir.
Okay, thank you. Thank you.
Thank
Best
you,
wishes.
sir.
Best
Thank
wishes. Next presentation is from A.S. Mathur and BP Singh.
Good evening. Good evening, everyone. This is Dr. A.S. Mathur from Department of Physics, Dr. Bhimrao Ambedkar University, Agra. Today, I'm going to present my work on simulation of metal chalcoriginite solar cells using SCAPs. Am I audible? Hello. Hello.
स्मिता मैम म्यूट कर लीजिए म्यूट स्मिता मैडम
sorry, sir.
Hello.
Thank you.
Can I proceed? Can I proceed now?
Please, sir. Please, sir. You can proceed.
Okay, so I'm going to present my work on simulation of metal chalcoriginite solar cells using SCAPs. As we talk about solar energy, it's the main benefits of solar energy is that it's renewable energy, it's easily and freely obtainable, it's eco-friendly, and it's free of contamination. The major advantages of solar cells include that they do not generate emissions or radiations, they require very little maintenance, they do not produce noise, they're clean and non-polluting energy sources, and no fuel supply is they do not have any fuel costs or fuel supply problems. But it still has its own limitations, like there are always intermittency issues regarding power generation. It has high initial costs, they can be damaged easily, they require large area, they cannot be used in absence of light from any source. So the working principle of solar cells, we all know it's based on the photovoltaic effect, which basically works on three basic steps: generation of charge carriers, separation of charge carriers, and collection of those photogenerated charge carriers. Here in this figure, we have shown how the electron from valence band is moved to the conduction band on absorbing photon, incident photon. When we talk about the solar cells, the material selection criteria is the most important aspect, which basically revolves around the semiconducting properties of the material. It should have strong optical absorption coefficient. It should be low cost and must be, its constituent elements should be abundant. It should be low cost. The material growth should also be low cost, while the it should be compatible with the existing technologies for fabrication of solar cells. Since we are talking about metal chalcoriginite solar cells, and we have used antimony sulfide Sb2S3 solar cells, it has direct band gap. It is abundant. It has very high absorption coefficient. It has low cost, and it's environmentally benign material. We have this is the structure which we have simulated for solar cells. These are the results and discussion part of our work. We have simulated these solar cells using the SCAPS software. It's solar cell capacitance simulator. It was obtained from University of Ghent, Belgium. It was developed by Professor Mark Bugelman and his team. In this work, we have studied the effect of absorber layer thickness, and we have seen that there is an enhancement in the efficiency with increase in thickness of the light absorbing material, that is Sb2S3 S3 material. If we closely observe, the rate of increase of thickness declines after 1000 1000 nanometers. So that's why we have optimized the thickness to at 1000 nanometers. The main reason for this improved performance is that can be attributed to the as we increase the thickness, it has more capability of holding additional photons as compared to the thin layer, and successively more pair of electrons and holes can be generated. We have studied the effect of ambient temperature also on the performance of solar cells. As we know that when solar panels mostly work when they are kept in sunlight, and they get heated by the sunlight falling on it. So the photovoltaic parameters, they also do get affected at higher temperatures. So there is a gain in energy of the electrons at higher temperature, and their recombination with holes takes place before reaching the depletion region and collection. So at higher temperature, solar cells become unstable. We have studied the effect of defect charge as well as concentration in the absorber layer. We have varied the concentration of defects in the absorber layer, that is Sb2s3 material, and we have also varied their charge types. We have studied the changes in their photovoltaic parameters with charge types of the defects. So we have observed that the photovoltaic parameters, they remain unaffected till the concentration of 10⁻14 per centimeter cube of defect concentration for all types of defects. This may be due to their lesser defect photogenerated carrier scattering at small concentrations, so we can see that the device performance is not compromised. But as we move from forward with higher concentration of defects, the performance of the solar cell decreases. In the case of neutral defects, we see that the performance defects degrades gradually on increasing the concentration from 10⁻14 to 10⁻16 per centimeter cube, and abruptly after that. In the case of defects of single donor type, we can see that the increasing the defect density, the photovoltaic performance decreases sharply and efficiency becomes very low at 10⁻16 per centimeter cube concentration of defects. So we have just concluded that from this study that the charge type of the defects as well as concentration, they play a significant role in influencing the photovoltaic performance of the solar cells. So now I would like to conclude that from this study, we have made some conclusions that antimony sulfide solar cells, they are easy to fabricate, they are low-cost materials, and they can be an alternative to the existing technologies. The thickness of Sb2s3 absorber layer in this study was optimized to be about 1000 nanometers, as the efficiency increased sharply from 500 to 1000 nanometers, but after that, the rate of increase of efficiency declined. This structure of solar cells, Sb2s3 series ZNO-AL structure, that shows better performance at lower temperatures also. But as we have seen, there is not much changes observed on increasing the ambient temperatures, which means that their performance does not deteriorate at higher temperatures, or we can say that they retain their PV performance even at higher temperatures. That concentration, we can also conclude that the concentration and charge type of defects should be highly controlled when synthesizing these type of solar cells, because they strongly influence their performance. Finally, we can say that the metal chalcogenide Sb2s3 solar cells, they have good projections of being used as photovoltaic light converters. We would like to thank Professor Mark Bugelman and his team for providing the support of SCAP's simulation software. Thank you.
Thank you, Dr. Mathur, for such an excellent presentation, and you are doing really excellent work. If any of our participants wants to interact Dr. Mathur, then okay, thank you. Thank you, sir.
Thank you.
So our next presenter is Dr. Jagdish Nehra. Nehra ji. Mathur sir, is a request to please off your screen.
Sure. I'll just.
Dr. Jagdish Nehra, are you there? Jagdish Nehra ji. Jagdish ji, are you here? If Dr. Jagdish Nehra is not there, then we can call to our next participant, Charu Dubey, Akhilesh Kumar.
Yes, sir.
Please, Charu ma'am, you're most welcome. Charu ma'am, you can present your screen.
Yes, sir. Yes, sir. Just a minute.
Yeah,
so
we
is
can
my
see
screen
your
visible?
Yeah, we can see your presentation and we can listen, please.
Okay. A very good evening to one and all present here. Myself, Charu Dubey, research scholar at Banasthali Vidyapith. The topic for my paper presentation is optical properties of CSPB X-ray nanocrystals and their applications in anti-counterfeiting. So here we will start with introduction, then research methodology, result and discussion, and then we will conclude. So starting with the introduction, counterfeiting of popular branded products is not a new phenomenon. However, over the last few years, public attention has been drawn to danger of counterfeit pharmaceutical products, fake electronic items, and many more. Anti-counterfeiting techniques which we use are holograms, barcodes, security inks, digital encryptions, and many more. Anti-counterfeiting technologies are added to products or the packaging to check whether the product is authentic or not. When we talk about halide perovskite with general formula AbX3, where A is cation, B is a divalent metal ion, and X is a halide, are a class of semiconductors that have potential to deliver cheaper and more efficient photovoltaics than silicon-based technology. So here, for the synthesis of CSPB-X3, where X can be Cl2, Br2, and I2, we have used hot injection method. In this method, 20 ml of 1 octadecene and a very small amount of PbX2 were loaded into 100 ml 3-neck flask and dried under N2 gas purging for 1 hour at 120 degrees Celsius. After that, 2 ml of dried oleamine and 2 ml of dried oleic acid were injected into the mixture. Now, after the complete solubilization of PbX2, 1.6 ml cesium oleate was injected at 160 degrees Celsius. Quickly after 10 seconds, the mixture was quenched into ice water bath, and after that, the temperature was decreased to 30 to 40 degrees Celsius. Now the mixture was centrifuged at 9,000 RPM for 10 minutes. Here are the images of samples which I have prepared with the same method, and also film was prepared by dissolving the polymethyl metacrystallate in quantum dots already dispersed in toluene. So for the optical studies of for the optical properties of CSPB-X3 nanocrystal dispersed in toluene, UV visible absorption and PL spectrum were recorded. And because of the time foundation, I could not show all the graphs of the samples which I have synthesized. So I have shown only the graph of CSPB-BR3. And it is clear from the graph that the absorbance is around 1, and the band gap was found to be 2.355 electron volt. Now again, I have shown the PL spectrum of CSPB-BR3. So for the PL spectrum, the PL spectrum was recorded using 367 nanometer excitation wavelength, and it shows a single sharp peak at 531 nanometer. Here is the image of printed pattern. Here's the image of pattern printed over black substrate and recorded under UV light of 367 nanometers. So conclusion, a systematic study on the colloidal preparation of CSPB-X3 nanocrystal has been carried out. The absorbance of CSPB-BR3 was around 1, and the band gap was found to be 2.355 electron volt. The PL spectrum shows the single sharp peak at 531 nanometers. Printed pattern showed the good emission under UV light. Thank you.
Thank you, Charuji, for your presentation of your research work. Any participants wants to interact with Charuji, Charu Dubey? If you don't have any questions, let's move to the next one. Dr. Devesh Tiwari.
Yes, sir.
Please.
Okay, sir, 1 minute.
All the participants are doing presenting excellent presentations. Now I invite Dr. Devesh Tiwari. You can present your screen and.
Sir, my screen is visible?
No, sir. And Dr. Tiwari will give his presentation on design and development of fractal microstrip antenna for more. You can go to share screen and then you can select the whole screen. Deveji.
Sir, is it visible now?
No, sir. You can go to share screen. You can go to share screen. Go to share screen first.
Okay, sir. Wait.
Then you can select the screen and then click the share button.
आनंद जी, हम नेक्स्ट के लिए चल सकते हैं क्या जब तक ये अपना तैयारी कर लें?
Please, sir, please. We can go to the next person. Sir, Deveji, you can prepare yourself. Try then.
Okay, sir.
Can we go to the next one? Anshika Bagla.
Yes, sir. Hello, sir.
Please, ma'am. All the participants are requested to be with their presentations. And
is the screen visible, sir?
Yeah, screen is very much visible. Please.
Okay. So good evening, everyone. I'm Anshika Bagla. I'm a research scholar in Department of Physical Sciences, Pzt Beam. And the title of my paper is PVDF.5, that is barium calcium titanate, barium zirconate titanate oxide, that is Bzt based nanocomposites for flexible energy harvesters and storage application. So from the title, it is quite clear that I'll be talking about energy harvesting. So the outline of my talk will be motivation. Then I'll be going through some introduction. After that, some experimental details and the methodology I've used. And after that, finally, I'll be discussing my results and discussions. So the motivation starts with, the first thing is energy crisis. Owing to the escalating worldwide concern over energy calamity and environmental issues, there's a need to look for an alternative renewable source of energy. Energy harvesting basically is scavenging energy by conversion of ambient energy present in environment into electrical energy for using in powering low power devices like Internet of Things, wearable health monitors, smart factory equipments, wireless inventory trackers, and many more. Basically to power the devices which are of low power and need to be charged repeatedly or uses batteries. And mechanical energy is the most abundant energy source and is easily convertible to other useful forms. So ambient energy put into use, especially mechanical vibrations. Now, piezoelectric nanogenerator to the rescue. Piezoelectric nanogenerators is a type of technology that converts mechanical energy to electricity. Piezoelectric nanogenerators are the approaching alternative choices for scavenging different types of waste mechanical energies. And also there is an increasing research in utilizing lead-free piezoelectric ceramic materials for energy harvesting due to toxic environmental effect of using lead-based piezoelectric ceramic materials. So now the introduction starts with what is piezoelectric nanogenerator. So piezoelectric nanogenerator is a promising technology for harvesting mechanical energy because of its ability to convert mechanical energy to electrical energy by means of piezoelectric material. When an external mechanical force is applied, the material accumulate electric charges, piezoelectric or ceramic materials have been used to the assembly of piezoelectric nanogenerators. By the image, it is clear that vehicle vibration, human motion, building or bridge oscillations, all these are low source of energy, which are used to convert to be used in different application areas like condition monitoring, power shoes, pacemakers, tire condition monitoring. There are so many application areas more, like sensors, actuators, filters, batteries, frequency controlling devices, pacemakers, heart rate monitors, implantable drug pump, brain pacemakers, and etc. etc. Now, for this, polymer nanocomposite is to be used. Now, what polymer nanocomposite is? Polymer nanocomposite is a composite in which we combine a polymer matrix with some kind of nanomaterial. In making of polymer nanocomposite, the aim is to take exceptional property like strength, stiffness, electric and thermal conductivity on a standard material. More specifically, we want to take a very small amount of nanomaterial and use it to significantly enhance the property of bulk material without a significant increase in its weight. Now, there are some piezoelectric polymers like PVDF and PVDF TRFE. PVDF is one of the most attractive and highly investigated candidates for mechanical energy and harvesting applications among materials. The feature of PVDF, such as high piezoelectric coefficient, like excellent stability, desirable fact. Hello. Okay. So some features are like high piezoelectric coefficient, excellent stability, desirable flexibility. Okay. Flexibility promoted its application in different types of nanogenerator. PVDF, TRFE are polymeric material typically used for electronic application. The image visible is a phase diagram of PVDF. As we can see, alpha phase, beta phase, and gamma phase is given. Due to the anti-packaging of molecules, alpha phase and gamma phase are less electroactive and beta phase is highly electroactive. So the aim was to achieve beta phase. Now the nano material was used was BCT BZT. Now why I chose BCT BZT is because it is environmental friendly piezoelectric ceramic that is a promising alternative to lead based piezoelectric material PZT, whose toxicity is well known. And to achieve beta phase, there are so many ways to enhance beta phase. One of them is adding nanofiller. So then a nanofiller I'll be using, I used is BCT BZT. Now the experiment which I performed, first step was to synthesize BCT BZT nanofiller by using sol gel method. Then it was distributed into two parts to check the performance of dopamine. So one was plain BCT BZT, which I named as WOTA, that is without dopamine added, and the other I added dopamine, that is BCT WDA, that is with dopamine added. Then the PVDF solution was prepared by using PMSO to dissolve PVDF, and at 80 degrees Celsius, when PVDF pellets was completely melted, nanofillers of BCT BZT was added on different amount, 10% to 60%, and then stirred continuously for 12 hours. And then there was a process of sonication for mixing of filler and PVDF. And then a homogeneous slurry was prepared, which was casted to a clean petri dish and kept at 60 degrees Celsius for solvent evaporation. A composite film was formed of a thickness approximately 50 micrometer. Now for the formation of device, that composite film was aluminum coated on both sides, leaving 1 mm at the edges. Sample was tested under a continuous increasing DC direct current field, and the leakage current through the sample were monitored to check breakdown strength. To test energy.
Anshika ji, it's a request to please conclude.
Okay. Yes, sir. So the device was formed in a rectangular shape size and cooled under 15 kilovolt per mm for 6 hours. And for mechanical excitations, periodic beating was used. And after that, there are XRD analysis of the sample prepared. As we can see, there are two, that is without dopamine added and with dopamine added. After the addition of dopamine, beta phase, we can see two beta peak was there. So beta phase increases by adding filler and dopamine. Then this is FE-SEM analysis. A, B, C, these images are with dopamine added ones, and D, E, F are the images of the sample in which dopamine was not added. These images are of 10%. I concluded, I got that low filler content gave larger grainer size and high filler content gave smaller grainer size. And okay, this was the chemical equation. And now these are dielectric permittivity graph, dielectric loss and tangent graphs, AC conductivity graph. And these are breakdown strength and related to filler content, energy density related to filler content results with dopamine added shows very great property in comparison of without dopamine added ones. Now these are the graph of the device which was polled and unpolled. So after polling, the device gave better result, and these are the final results which I got. The charging was at the time of charging, the V output was 0.73 volt and time was 18.04 seconds, and the time it took for discharging was 30 seconds. And these are the other one is for polled device, in which V output was higher in comparison of unpolled devices, that is 1.47 volt in the time 16.21 second, and it took discharging time 29.49 second. Thank you.
Thank you, Anshika ji, for a elaborated presentation of your research work. You're doing good work.
Thank you so much. Thank you so much, sir.
Any queries or questions will be welcome. So next presentation is Mohammed Soeb. Mohammed ji, Soeb ji, are you here?
Thank you so much, sir.
Mohammed Soeb. Mohammed Soeb ji. If Mohammed Soeb ji is not there, can we call Bharti Sharma and BP Singh? Bharti Sharma. Paper number 14, Bharti Sharma. She may not be there. Paper number 15, Dr. Deepmala. Dr. Deepmala, are you here?
Excuse me, sir, I am here. Bharti Sharma.
Bharti ma'am, you're welcome. And please share your screen to present.
Is my screen visible, sir?
Yeah, it is starting. We can see your screen and we can listen you, please. And madam, please stick to the time because it's already 5.
Okay.
5:50.
Okay, sir. Good evening.
Anand sir.
Sir, excuse me, sir.
Yes, sir.
Excuse me, Anand sir. Did you get my
My
voice?
name is Bharti Sharma and I am here at the
Anand sir, did you get my voice?
Yes, sir. Please.
Sir, my turn. You have to miss my turn, sir. T39, sir. Vijayan Pandey.
I don't know, sir. If I missed, I'll again
next
time.
Actually, sir, can you see the schedule? So
sir, you also skipped my chance, sir.
Yes, Chavi. After this is my chance.
Okay. I'm sorry. Sorry, sir. Sorry, sir.
Okay,
sorry, sir. I missed some of the names. After presentation of the Bharti,
thank you, sir.
I will definitely.
Thank you, sir.
Sorry. It's from my side. I'm sorry. Please.
Shall I continue, sir?
Please, ma'am. You can continue.
Okay, good evening, one and all present here. My name is Bharti Sharma and I'm giving a presentation on the performance enhancement of BHJ organic solar cell by incorporating carbon nanotube as transparent conductive electrode, that is TCE. So this is the introduction that we have already know that the solar cell have got much consideration due to their the only reliable source on the non-renewable energy from the future aspect. And here we are using non-fullerene acceptor bulk heterojunction organic solar cells, because these solar cells are the substitute of fullerenes, because fullerene sometimes reacts with temperature and other elements, and they make another molecules which degrades the device. So we are using here non-fullerene acceptor material. So this is the basic structure of our solar cell. In the solar cell in above layer, we can see there is glass which is receiving the sunlight, and below the glass there is transparent conductive electrode, your transparent conductive oxide, and below P.PSS, which is HTL, active layer. Actually, active layer work for the generation of electron holes, and electron travels to the electrodes, cathode, and holes travel to the anode. And that's way we get the current generation in organic solar cell. These organic solar cells are very useful because they are lightweight. They can be printed like paper, as we can see on the screen. They can be printed with the help of the 3D printer, and they can be pasted on the walls. As we can see, they can be pasted on the window, and they can supply energy. They can supply the power for us. So these in these organic solar cells, we are using TCE, a transparent conductive electrode, which is the major component of these solar cells. ITO is the most popular and widely used commercial TCE nowadays, but there are some drawbacks with it, like this is brittle in nature, and sometimes it is found that it has some cracks also, which degrades the device. So we need to have some alternatives of ITO, and here we are using carbon nanotube to replace ITO as an alternative. So here we have modeled and simulated the NFA-based organic solar cell using CNT doped with molybdenum trioxide as a TCE to optimize photovoltaic parameters such as VOC, JSC, fill factor, and power conversion efficiency, which are the important photovoltaic parameters for the device simulation of the organic solar cells. These are the carbon nanotube. These are carbon nanotubes like single wall carbon nanotube, double wall carbon nanotube, and multi-wall carbon nanotube. Here we have used the mixture of these carbon nanotubes. This is the materials and method. I would like to skip this. Now I'll come to result and discussion. So this is our IV curve, which we have obtained during the simulation. And we can see in the curve that the IV curve is increasing as we are increasing the concentration of carbon nanotube. Okay, so we are getting the fill factor about 63.14 and PC around 27%. Short circuit current density around 38%, 38 milliampere per centimeter square, and open circuit voltage around 0.9371 volt. So these are the very outstanding results, and they can work in future aspect. Also, we can see the external quantum efficiencies around 95% for 1.0 doped CNT. This is also the outperformed result by these organic solar cells. We can use them for the future aspect. So this is the conclusion that when we have compared with ITO, CNT contacted solar cell showed significant improvement in all PV parameters. And this improvement is also linked to EQE spectra, that is quantum efficiency spectra, with nanotube having a greater quantum efficiency over a wider wavelength range. At last, we have got the PC of 27.57% with 1.0 CLP. Thank you everyone for being a patient listener.
Thank you, Bhartiji. Now I have left some of the names. So let me call Girish Narayan Pandeji.
Thank you, sir. Thank you, sir, for your nice cooperation. Maybe you are doing very work hard. Very good afternoon to all of you, sir.
Sir, you can present your screen. And
yes, sir.
Start.
Thank you, sir. Thank you, sir, for providing me chance. I thank to organic committee to providing chance for me to express my view about my research. So the topic of my research today, paper presentation is enhancement of photonic band gap in one-dimensional.
Excuse me, sir. ये सर से पहला नंबर मेरा है, sir. छवि.
Okay, madam. After this, you can go. Okay, ma'am.
Okay, okay, okay.
One-dimensional plasma dielectric ternary photonic crystal. So before, sir, I'm starting this one. This is the outline. My talk is first. This is about abstract introduction, mathematical analysis, result, discussion, and conclusion. So I've taken the alternate. We have thoroughly studied about the multi-layer structure. This is hyperbolic metamaterial based on plasma photonic crystal, and in this study, we have to study about the reflectance, transmission, and absorption of the multi-layer ternary photonic crystal. So I want to discuss about the next one. This is what is actually I want to discuss about photonic crystal means we have taken the periodic alternate torque, alternate layer of periodic structure means variation of effective index. So we have taken this is the variation of effective index material to two materials, and we have incident the electromagnetic waves. So so this is what the photonic means. Photonic crystal means we have taken photon electromagnetic energy of as you know very well, and crystal means we have taken the solid that is repeating pattern of atoms, ion, and molecule. These are the examples of the photonic crystal. So this is here. So the Yalunich was the first scientist. Yalunich and John both have published in 1987. So both have given simultaneously the idea of photonic crystal. So the idea of photonic crystal is interaction between the light and the matter. So we have taken the photonic crystal. Photonics means we have taken the alternate variation of photonic crystal, and we have propagated the electromagnetic waves, and we have studied about the reflectance, transmittance, and reflectance, transmittance, and the absorption. So this is actually electronic band gap. Everyone knowing about electronic band. This is rising due to electrons, and photonic band gap is rising due to the photon. So this is the photonic band gap, and we have make interaction with the light with the matter. So I'm talking about types of photonic crystal. This is the one-dimensional photonic crystal. This is two-dimensional photonic crystal, and this is the three-dimensional photonic crystal. So this is the systematic diagram of photonic crystal. So I'm talking about the plasma. What is this? I'm talking about the plasma photonic crystal. We have taken alternate variation of different refractive materials. So we have taken alternate dielectric plasma dielectric material in this my study. So this is the dielectric constant, and in my previous study we have taken the ternary photonic crystal. Ternary means we have taken three structures. This is the hyperbolic material and dielectric, and we have taken metamaterial. So we have to calculate the absorption, reflection, and transmittance behavior with the help of transfer matrix method. So we have using the TMM. This is well known as TMM method, transfer matrix method. So we have used this formula for transmittance. This is the formula is used for transmittance. It is clearly showing here, and this is the formula which is used for the reflectance, and this is the formula for absorption, 1 minus R minus R minus T. So using this formula, we have plot graph, and we have taken, this is the fundamental condition for the by study. So we have taken the ternary photonic crystal, hyperbolic metamaterial, and plasma photonic crystal. So we have to study about the reflectance, transmission, absorption. So we have plotted graph between the reflective, transmission, absorption versus normalized frequency. We have obtained this graph. So we have observed the number of photonic band gap. This is the band gap. This is the red light. This is for absorption, and blue for the reflectance, and green for transmittance. And we have obtained the photonic band gap. And we have observed that the multiple photonic band will be observed. We can also study about the variation of thickness. We can also study about the better reflective index. And we have also studied about the variation of the number of layers. So this is my study. So thanks to all of you for my, and this is used for, it is used as RIE-NCERT, and absorption-based devices. Thank you, Anand sir, for your cooperation and providing me chances to my ideas.
Thank you, Dr. Pandey, for the wonderful presentation. If you have any queries, you can ask Dr. Pandey. So
you ask me, sir.
Anybody? Any questions? Okay. Next presentation is from Chhavi Mithrawal.
Okay, thank you, sir. Anand sir, once again, Anand sir, thank you, sir.
Thank you.
Yes,
thank
sir.
you. Chhavi ji, please share your screen and please present. Pandey ji, you can stop your screen, please.
Okay.
It's a request to all the participants that already we are running short of time. So please be in brief, directly come to the processor or what you want to say and then come to conclusion. Chhavi ji,
sir, you can see my screen, sir?
Yeah, we can see your screen and you can start.
Okay, sir. Okay, sir. I am Chhavi Mithrawal, research scholar from Vanasthali Vidyapith. I will be presenting my paper Microstructure and Electrical Properties of MnO2 Modified CSBT for High Temperature Applications. So sensors and actuators are really needed for industries that can function at elevated temperatures. So out of all the available piezoelectric material, we have focused on BLSFs due to their better properties. So here we have focused on CaBi4 Ti4O15 due to their high TC, low dielectric loss, low electrical conductivity, and low piezoelectric coefficient. So in order to further improve the piezoelectric properties and other electrical properties, we have to get higher piezoelectric coefficient. So we have Ca2 plus has been substituted partially by Sr2 plus in the composition CSBT. So for further improvement of the properties of CSBT, there is an addition. We have added MnO2 as an additive to the composition. So now focusing on the experimental work. So there is a preparation of different composition of CSBT with different percentage of MnO2. The powders were further converted into form of pellets. The pellets were sintered at different temperatures ranging from 1050 to 1080 degrees Celsius. The XRD was done of the pellets where we check the purity of the phase. SEM was done to check the macrostructural properties. And finally, the dielectric measurements were done using the impedance analyzer, where we analyzed the different electrical properties and decided the better composition. Now moving towards the results and discussion. Towards the left side, you can see the XRD patterns, unit cell volume and Raman spectra of CSBT Mn. So in the XRD pattern, we can see the peak is near the 33 degree. So the maximum peak can be observed at 119, which meets the criteria for BLSF. The unit cell volume has also been calculated with the help of XRD, with the help of the graphs, and Raman spectra was also recorded. And towards the right side, you can see the EDS spectra. So with the EDS spectra, we can see there was a uniform distribution of the additive, that is MnO2, throughout the composition. And since bismuth is a volatile element, we can see that the bismuth has also evaporated uniformly throughout the whole surface. Now we can see the SEM micrographs. So here, when we focus on the E portion, so the SEM was done of the cross-sectional area of the CSBT 8 Mn. Here you can see the plate-like structures. This is due to the growth of the structure during along the C-axis. So here we can see the relative density was highest of the CSBT AMN composition. Now focusing on the W upon L ratio. So here we can see that W upon L ratio changes notably with the addition of MnO2. The MnO2 does not accelerate the grain growth process, but with the help of addition of MnO2, pores were reduced, which relatively improved the density. Now moving towards the relative permeability and dissipation factor. Here we can see with the help of we have plotted different relativity, different graphs of relative permittivity versus temperature for different compositions. Now TC came near 600 degrees Celsius for all the compositions. Now dissipation factor was also low, up to 400 degrees Celsius, which means these pellets were, these materials are good for piezoelectric properties, and further the properties can be improved of these materials. So now moving towards the AC conductivity variation.
Madam, please continue.
Okay,
please
sir.
Continue.
AC conductivity also increased linearly and constantly. Now moving towards the DC conductivity graph, we can calculate the activation energy with the help of DC conductivity graph. Now complex impedance plot, we can see the single semicircle is attributed to the single relaxation process, and impedance is primarily due to the grains only. The capacitance was the highest for CSBT4 composition, and resistance was also the lowest. Resistance was also the highest for CSBT4 composition.
Please
okay. So CSBT4MN was the best composition out of all the compositions done.
Thank you.
Thank you, sir.
Thank you, Chaviji. It was nice. Next is M. Roy and Lokesh Sudha.
Sorry, sir. Sir,
Tiwariji.
Okay, sir.
Tiwariji will take you, but today, now I have announced the name of M. Roy and Lokesh Suthar. Okay, they are not here. So, Roy sir, please share your. Please share your screen and present.
Yes, sir. Yes, sir.
It's a request, Mr. Lokesh ji, to please wind up within the time, please, sir. And after that, we'll request Tiwari ji to please be ready.
Sir, my screen is visible?
Yeah, your screen is started to be sharing. Yeah, screen is visible. Please go ahead.
Thank you, sir. Good evening, everyone. Myself, Lokesh Sudha, Research Scholar, Department of Physics, ML College Institute, Udaipur. Today, I am going to present a research article entitled Synthesis, Structural and Electrical Properties of Multiferroic YF3 Ceramic. Now, this is the general introduction about perovskite structure and the multiferroic properties. The mineral perovskite was discovered in Ural Mountains, Russia by Gustav Rose in 1839 and received this name in tribute to the Russian mineralogist Lev Alkasovich van Perovsky. The name perovskite was originally used to describe the mineral calcium titanate, but currently it is used to specify the specific group of oxides with general formula AbX3, where A and B are cations and X is an anion. The figure shows the AbX3 structure, where A cation is located at the corner position of the cube, while the B cation is located at the body center position of the cube, and the X anion is located at the face center position of the cube. Some perovskite type materials show multiferric behavior, and multiferric property means the existence of 2 or more ferroic orders in the same phase at a time. This effect was first observed in borasites. This is the general introduction of yttrium ferrite. Yttrium ferrite is a member of perovskite structured oxide group AbO3. The most attractive feature of this compound is that it simultaneously displays 2 or more properties like ferroelectricity, ferromagnetism, and ferroelasticity. It is prepared mostly in ceramic form using solid state reaction method, sol gel method, wet chemical method, autocombustion method, gel casting, etc. And the nil temperature for yttrium orthoferrite is observed around 655 Kelvin. Now, this is the synthesis mechanism of YFO3 using solid state reaction method. This is the flowchart diagram. First of all, we take raw materials, then we mixing it, then we add some acetone, then we grinding, then calcination, then regrinding. The process of grinding and calcination was repeated several times, and then the powder was pelletized using hydraulic press and a cylindrical die. Then the prepared pellet was sintered, and then we make electrodes on the pellet, and then the pellets were ready for various measurements. Now the second figure is showing. Now the second figure is showing the concept of grinding, in which the surface area is enhancing using the splitting of particles for a constant volume. Now this is the detailed flowchart diagram for the synthesis of yttrium orthoferrite, for which we have used yttrium oxide and iron oxide as raw materials. Then we have mixed and grinded it for manually 6 hours. Then it was calcined at 873 Kelvin for 6 hours. Then it was regrinded for regrinding for 4 hours. Then recalcined at 1173 Kelvins for 12 hours. Then regrinding for 4 hours. And finally, it was sintered at 1473 Kelvin for 2 hours. Then it was ready for the various measurements. Now this is the result and discussion part. Now this is structural analysis. The first figure is showing the room temperature X-ray diffraction pattern with Rectilinear fitting. It is clear from this figure that there is no major impurity peak observed, which proves that the material has been successfully synthesized in the desired phase. Also, this XRD profile is well matching with the JCPDF file number this, and the Rectilinear analysis has confirmed the orthorhombic symmetry with the space group PNMA, and the intensity of the impurity peak is very low, which proves that these impurity peaks are not affecting the overall structure of the synthesized material. The second figure is showing the three-dimensional crystal structure of the prepared material, which has been generated using the Vesta software. The crystallographic information file, that is known as CIF file, which was observed using the Rectilinear analysis, was fed into the Vesta software, from which we have observed the three-dimensional crystal structure of the prepared material. Using this material, we can calculate bond angles, bond lengths, etc. And the atomic positions have been marked in the side portion. Now,
okay, please conclude.
Now this is
okay,
the
conclude
parameters we have calculated from. Yes, sir. Yes, sir. Now this is about the electrical analysis, and this is the dielectric constant versus the frequency curve, and this is the dissipation factor versus frequency curve. Now this is dielectric constant versus frequency curve. Now this is SC conductivity curve, and this is DC conductivity curve. We have calculated the activation energy, which was observed around 2.1 electron volt from the slope of the DC conductivity curve, which shows that the material is showing the anti-CR effect. And this is conclusion. The high dielectric constant and high activation energy, that is around 2.12 electron volt for DC conductivity measurement, shows that the material is highly insulating, which is the characteristics feature of the good dielectric material and which is useful for device applications. The negative temperature coefficient of resistance effect for this material suggests that this material can be used for construction of electronic components like thermistors, thermoelectric sensors, etc.
Very good.
Thank you.
Thank you, Lokesh. Yeah. Now we'll call Dr. Devesh Tiwari ji. Devesh ji, present your screen.
Yes, sir. Okay, sir.
Please. This time we can see your screen, please. And please, it's a request to complete it within 4 minutes, so that we can finish it on time. Please.
Sir, my PPT is visible.
Yeah, it is very much visible. We can listen you and we can see you, please.
Okay, sir. Good afternoon, all of you. Good evening, everyone. My name is Devesh Tiwari. I have completed my PhD from Department of Electronics and Communication, University of Allahabad. Today's my topic is design and development fractal microstrip antenna for modern wireless communications. Our today's topic is there is a abstract, then introduction, and then proposed model, then result analysis and conclusion and references. This is the abstract. Here a proposed research work aimed to develop a miniaturized very small antenna to design for mobile communication, satellite, radar applications. For this, we have used the fractal concept to miniaturize the microstrip antenna. Microstrip antenna design using fractal technique such as Sierpinski gasket, Sierpinski carpet, coarse snowflake structure, etc. have been many characteristics for size reduction and increased electrical length for multiband and ultra-wideband applications. Recently, microstrip antenna is very much popular because of its attractive features, such as it's a very low weight, low cost, low profile, and conformal means we can can be easily integrated into microwave integrated circuit. The two main drawbacks of microstrip antenna are low gain and narrow bandwidth. So our aim to overcome these limitations, and the microstrip antenna antenna is cover the entire broad frequency range from 100 megahertz to 100 gigahertz, and the work aim is to develop a microstrip antenna for 5G, 6G applications, IoT applications, satellite and radar applications, biomedical applications. For this purpose, a basic overview of microstrip antenna: there is upper side and below side of a dielectric substrate. There is a conductor plate, and this is a dielectric we are using. So microstrip antenna is a kind of printed antenna and consists of a dielectric substrate sandwiched between two metallic plates known as patch and ground plane. So these antenna is always useful. We are using in our mobile phones, satellite, radar, wherever we are using. It is like electronic eye to the world. So we can talk with this, or we can hear by using the antenna. Here the fractal concept given by in 1975, the Mandelbrot initially developed the concept of fractal microstrip antenna. So fractal antenna is using the concept of fractal geometries in the designing of antenna. So the two main characteristics of fractal antenna is, one is space filling. That is, whatever space we are having, we can utilize our space, and the self similar property. Like in the nature, nature is also considering there like a fractal structures, and by using the concept electrical, there is a mathematical analysis has been developed by many scientists like Sierpinski cascade, Koch curve, and Minkowski curve. There is lot of mathematical equations has been developed by analyzing the antenna. Here the work introduction is now I am going to present a multi-band high gain miniaturized microstrip antenna, where we have reduced the size by 68.4%, and we have increased the electrical length by 168.8% in its perimeter, and it is used for hexaband applications in C, X, Ku and K band applications, which is useful for 5G and IoT applications, satellite and radar application. Here I am using HFSS simulation software. Here the step process is, initially I have used a hexagonal structures. Then in first step there is a triangular slot is loaded in the first step. Again in the next iteration, in each side there is a repetition of the structure, and finally we have designed the microstrip antenna. And this is the structure of top layer, side view, and the bottom view of this structure, and it is considered as electrical RLC circuit considered, which will provide the resonant frequency of the antenna. So this is the basic design specification, where we have used the length, width of the antenna and miniaturized their dimensions. Since there is a very less time, so we have only considered whatever we have achieved. This is the current distribution of the antenna in different resonant frequencies. Initially it is 3.46, then 8.28 and 12.26, 17.21 and 23.40, and last one is 26. So this is used for very 5G and IoT applications of antenna. And in this particular frequency, there is at 4 frequency, we are getting circular polarization in the axial ratio below 3 dB. So this is the
Please conclude.
Yes, sir. In a quick chamber radiation pattern graph, this is nearly omnidirectional radiation pattern, which is distributing in all over surroundings. And this is the gain and efficiency of our result. So we have achieved almost 9 dB gain and efficiency up to 86%. So this is the conclusion that we have analyzed our antenna using HFSS and fabricated and achieved the multi-band behavior at 6 frequency with the radiation patterns with return loss of given almost 25 dB. So this is our achievement, and this is used for modern wireless communication like 5G and IoT applications. So these are the references. And
thank you. Thank you, Devesh. It was really nice to listen to you. You presented very excellently. Good work. KK Chand, presentation number 11. Okay, Mohammed Shoaib. Dr. Deepmala?
Yes, sir, I am here.
Deepmala?
Yes, sir.
Please, Deepmala ji, please come. You can present your screen. Please.
The screen is visible.
Your screen is very much visible. We can listen you. Plus, please, it's a request to finish it within the time. Directly,
yes,
you can
yes,
present your procedure and come to result and discussion, and then last.
Yes, sir. Yes, sir.
Please.
Good evening, sir. A comparison of bonding parameter of rare earth complexes in different amino acids. Actually, sir, I have taken two amino acids, neodymium and erbium. And neodymium and erbium, these are mainly rare earth element. And I have taken amino acids, glycine and arginine and thiourea as secondary ligands. Sir, actually objective of this study is to compare naphthalenic ratio of neodymium and erbium complexes, and second is to express the relation of energy levels of different complexes, Slater-Condon parameters and bonding parameters. Hypothesis is this: when beta naphthalenic ratio is greater than 1, then complex is ionic, and when this is less than 1, then complex is covalent. And this is method and procedure. With neodymium as one of main rare earth, glycine primary ligand, and thiourea as secondary ligand, I have prepared solution in molar ratio 1:2:1. And this is spectrophotometer with which I have taken the reading, absorption curve. In case of neodymium, I got 10 peaks, and in case of erbium, I got 8 peaks. And these are the position of peaks. This is the graph of neodymium, glycine, thiourea in the molar ratio 1:1. This graph is showing 10 peaks, and this is the graph for erbium, and this graph is showing 8 peaks. And this is again graph of neodymium, but with arginine. I have changed the amino acid, and this is with erbium, and this is the table 1: neodymium, glycine, thiourea, and erbium, glycine, thiourea. In this table indicates that for neodymium, naphthalenic ratio is greater than 1, and for erbium, naphthalenic ratio is less than 1. And all neodymium complexes are ionic in nature, and all erbium complexes are covalent in nature. And conclusion is this: for rare earth complex, bonding is considered to be ionic because of inert gas configuration and well shielding of 4f orbital. But in case of erbium, bonding is covalent. And these are the references. And thank you, sir.
Thank you, Dr. Deepmala. It was really excellent, nice to listen you. Next is Dr. Sarita Chandramohan Singh Negi. Saral Kumar Gupta.
Yes, sir.
Okay, please share your screen. Sarita Yadav, share your screen, please. Dr. Deepmala, please, you can share off your screen. It's a request, Dr. Deepmala, to Deepmala madam. Yeah. Sarita Yadav, please.
Yes, sir.
Sarita, yeah, please share your screen and be on time. Please finish it within 3-4 minutes, please.
My screen is visible, sir?
No, ma'am.
Sir, my screen is visible?
No, ma'am, it's not visible. Go to share screen and then please go to share screen.
Yes, sir.
Now your screen is visible, right? Please finish it in time. Sarita, continue. Yeah, we can see you. Please go ahead. Unmute yourself. Sarita Yadav ji, please unmute yourself. You are muted. Sarita ji, your mic is muted. Please unmute yourself. Now you can speak. We are not able to listen your voice. We are not able to listen your voice. We are not able to listen your voice, please. Sarita ji, we are not able to listen your voice. Can we call to the next participant? Sarita ji. Sarita ji, we are not able to listen you. You can join again and then present, please. You can join again and then present. Something maybe, some issue may be there. Stop. You can click to stop sharing. You can click to stop sharing. Yeah. Now speak. Maybe some issue is with your system. You can work on your system, then will come. Can we call to next participant, Meenakshi Sharma?
Yes, sir. I'm present here.
Meenakshi
Sir.
Sharma.
Yes,
Please,
sir. I'm present.
Meenakshi, you can please continue. Please continue. After that, we can again will come to Sarita Yadav.
Sir, my screen is visible to you?
Yeah, it is very much visible. You can present your screen actually.
Yes, sir. Sir, is it visible to you?
No, your presentation is not visible.
Sir, 1 second.
Yeah, your screen is now presentable. Please go ahead.
Good evening to all of you. My name is Meenakshi Sharma, research scholar, Banastili Vidyapeeth. My today's topic for the talk is low band gap polymer based nanocomposite to enhance the optoelectronic properties. Here is the content for my talk: motivation, device structure and working, result and discussion, and the conclusion. Motivation. Organic photovoltaic energy conversion is the most renewable energy source because of the advantages like non-toxicity, lightweight, flexibility, color tunability, and the most important, their cheap production. Secondly, the intrinsically conducting polymers are most favorable because of their low band gap, stability, and redox active properties like polyanyl and aniline. Next is the device structure. Here is the device structure. Firstly, the ITO coated glass substrate we have used. Then P.PSS is spin coated for HTL. After that, PANI and ICBA used as the active layer. After that, PCBM used as ETL, and the aluminum electrode deposition is done by the thermal evaporation unit. And the energy level, energy band diagram is clearly shown here for the transportation of electron as well as the hole. And next is the result and discussion. We can clearly see the absorption spectra for the active layer as the peak for PANI and ICBA clearly visible at 340 nanometer and the 500 nanometer. As you can see, clearly see that the low band gap polymer increase the absorption area so that the number of photons absorbed increased for this particular optoelectronic device. And next is the FE-SAM image, where we can clearly see the presence of PANI flakes and the ICBA, which is the Fullerene derivative. And next is the result discussion for the electrical properties, like where we can clearly see that the increased photocurrent is observed in the condition of illumination, and the ideality factor is reduced for illumination reason because of the reduced recombination. And the detectivity of the device is a function of applied voltage. So here we can see the increased detectivity of the device. And similarly, there are the impedance parameters shown clearly, which shows the increased lifetime of the charge carrier. And the conclusion: low band gap polymers can be easily developed as a photoactive layer of the device, as we have demonstrated the efficient photo detector. UV absorption reveals the increased absorbance due to the presence of low band gap polymer, and the IV characteristic evaluate the increased illumination current. Impedance spectroscopy shows the enhanced charge properties, and result shows that the low band gap composite can be the potential material for high performance optoelectronic devices. Thank you so much.
Thank you. Thank you, Meenakshi ji, for the nice presentation. Now, can I ask Dimple Yadav? Dimple Yadav? Okay, Dimple Yadav is not there. Seema Verma? Seema Verma? Chandra Mohan Singh, Negi, Saral Kumar Gupta?
Yes, sir,
Okay.
I am present. Yes,
They are
sir,
not
yes,
there.
sir, I am present.
Seema ji, present your screen and
Yes, sir.
Please.
Sir, sir, it's visible.
Yeah, your screen is very visible. It's a request to please be on time. Please finish it within three.
Okay, sir.
minutes.
Okay, sir. Good evening. I'm Seema Verma, research scholar in Venusthali Vidyapeeth, and my topic is in active layer metal oxide of nanocomposite with polymer-based photovoltaic devices. And my content is motivation, device structure, result discussion, and conclusion. And PTAA, a polyvinyl triamine semiconductor, is a great P-type semiconductor, which is a great stable glassy polymer and has good ionization potential for thick film diodes. And here I fabricate a device structure which is a PTA and ZNO nanocomposite and only PTA based devices. Okay, now this is the device structure where I use that the P.PSS as the ETL, as the HTL and TiO2 as the ETL, and there is the corresponding energy level diagram which is shown in figure 1b. And now this is the result and discussion part of my work. This is the UV absorption spectra visible clear to the pristine PTA as a 420 nanometer wavelength, which is shown, and is the FSM image, and which is shown is a better dispersion of ZNO with the PTA to enhance the photovoltaic performance. And the Raman spectra will be shows the interaction between the ZNO and the PTA material. And this is the current voltage measurement graph, which shows the PTA with ZNO nanocomposite shown a great current, display a great current value, and as compared to the only base PTA based devices. And this is the conclusion. The interaction between the nanocomposite device comprising the composite of ZNO and PTA have been fabricated and characterized. Interaction between ZNO and PTA has been confirmed by the study of Raman and absorption spectra also. And the PTA ZNO nanocomposite base device exhibit relatively large current levels under dark condition and illumination condition. And this work illustrated the great potential of PTA ZNO nanocomposite for application in a wide range of optoelectronic devices. Thank you.
Thank you, Seema ji. Thank you. Next, can I have the next one is Harshpreet Chima. Harshpreet. Okay. T Karunamay, S.K. Das. T Karunamay, S.K. Das. Professor P.C. Agarwal. Vedika Yadav. Vedika Yadav. Vedika Yadav. MS Anwar.
Yes, sir.
Please. Anwar sir, you can present your screen and share.
Okay, sir.
You can share your screen. Anwar sir, please share your screen.
Yes, sir. I am sharing.
Yeah, your screen is started to be shared now. Please.
Okay. My screen is visible, sir?
Yeah, your screen is very much visible. Please.
Yes, sir. Myself, Dr. Mohammed Shafiq Anwar from Aligarh Muslim University, and I'm going to present my research work on microwave-assisted hydrothermal synthesis of titanium dioxide nanorod for photovoltaic application. Basically, it comes under the nanoscience, and nanoscience is the branch of science which deals with the materials in the range of 1 to 100 nanometers. And it started with this concept is started with the lecture by a renowned physicist, Richard Feynman, by entitled "There is a plenty of rooms at the bottom." Basically, nanostructures have different kind of structure from flowers, belts, sheet, wires, tubes, rods, and the properties, their physical and chemical properties changes according to their morphology. So with this motivation, we have synthesized the titanium dioxide nanorods, and I'm skipping the introduction part. I'm going to directly to our research goal. We have synthesized this titanium dioxide nanostructures for basically for photocatalytic application, and this is the schematic diagram for the synthesis of titanium dioxide nanorods using microwave assisted hydrothermal. This in picture we can see this is equipment is a microwave assisted hydrothermal, and this is the results. First, this is the X-ray diffraction result of our edge synthesized titanium dioxide nanorods with a different reaction time from 30 to 60 minutes. This X-ray diffraction shows that all samples have a tetragonal rutile crystal system without any impurity. Please, it's okay. And it shows that crystallinity of nanorods increasing with increasing the reaction time. And FE field emission scanning electron microscope results shows that the morphology of as prepared nanorods for 30 minutes and 45 minutes and 60 minutes. We see that when we increase the reaction time of a synthesis, nanorods length as well as diameter increasing, and also the branching of nanorods also increasing. And for the 60 minutes, it shows that due to over branching of nanorods, also deformation in the structure is observed. And here in table, we clearly see that increase of length of nanorods with increasing the reaction time. And this increase in length of nanorods is attributed to the absorption of C-tab on the polar surfaces of titanium dioxide. To get more insight of microstructure and crystalline behavior, we performed the Raman spectroscopy of as prepared samples. And it shows that there are different Raman vibration band of titanium and oxygen bond, and it's all the band attributed to the pure rutile TiO2 crystal system. And also there we observed extra broad band at 238 wave number, and that's attributed to the disorder effects. And to calculate the optical band gap, we performed the UV visible absorption spectroscopy, and we calculated from that, and it's plotted in the this diagram, that optical band gap for the 30 minutes of samples was observed to 4.83 electron volt, and it decreased monotonically with the increase of dimension of nanorods. And for application point of view, we performed the degradation of methylene blue dye with irradiation of UV visible light on the solution, which contained our nanorods, titanium dioxide nanorods. And in figure we can see that this figure shows the result of degradation of methylene blue dye with a different time interval from 0 to 75 minutes. And it was observed that after 60 minutes, almost more than 50% of dye is degraded. And it's also clear from the picture, we taken the solution picture, after different time of interval of exposure to the light, and it shows that at starting at 0 minute it shows the complete blue color, and after 60 minutes this color is degraded. That means dye is degraded. So it shows that this is a good our synthesized titanium nanorod shows a good photocatalytic activity for the water purification. Thank you. Hello. Hello, sir. You are muted, sir. Again.
I'm sorry. Thank you, Anwar sir, for the excellent presentation. You're doing good work. Please, best wishes. Next, can I call Pankaj Didwania? Pankaj Didwania, are you here?
Sir, I'm ready. Sir, Sarita, I'm ready.
Sarita, I know, but first I take Pankaj Didwania. Pankaj Didwania, are you there?
Yes, sir.
Pankaj, are you there?
Can you hear me, sir?
Yeah, I can hear you. Okay, yes, go ahead. Pankaj Didwania is not there. So we have one left, and that is Sarita. Pankaj, you are here. Okay. Pankaj, please share your presentation. Share your screen and presentation.
Yes, sir,
please.
I'm here.
Pankaj, let's, your screen is about to visible. Please. Yes, you can start speak. You can start speak. Please. Pankaj, you can start speaking. Your screen is about to visible. I don't know. There may be some network problem maybe there. So can you again share your screen, because your screen is not visible. So in between, can we call Sarita Yadav? Sarita, are you here? Sarita?
Yes, sir. Yes, sir.
So Sarita, please share your presentation, please.
Yes, sir.
Pankaj, sure. I hope there is some network issue with you. So in between, we'll take the presentation from Sarita and then we'll call you. Sarita, you can proceed. Please finish it within 3 minutes. It's already 6:10.
Okay, sir.
Directly come to the processor or the thing, whatever you are dealing, please.
Okay, sir.
Next.
I'm Sarita, research scholar, Banastali Vidyapeeth, Rajasthan, and my topic is design of lead-free perovskite solar cell using Centaurus TCAD simulation. These are the content. These are the motivation. Device structure. The light strike the FTO end, and CSSNGI3 is chosen as a principal light absorber layer placed between the ETL and the HTL, and FTO and silver serving like the front connection and the rear metallization. These are the parameters that are used in my research work, and that is a simulation methodology. The drift diffusion transfer model is used for electrical simulation, electrostatic position equation, as well as continuity equation of both charge carrier are solved repeatedly, and the optical intensity as well as optical generation rate was calculated using the transfer metric method. Result and description: the energy band diagram of PSC. It is obvious that the high energy barrier at the absorber and ETL and HTL and absorber interference prevent photo-generated minority carrier passes from the perovskite toward the charge-specific region. These are the JV characteristic and the quantum efficiency of PSC. Electrons and holes are travel ETL to HTL. As a result of the junction field, a voltage is generated when electron and hole are accumulated at the anode and the cathode, and the JC of 19.86 and VOC is 0.81 and fill factor 76.81 and the power conversion efficiency 12.4% is obtained. Absorption thickness. The absorption thickness has a major effect on the device performance. The thickness of absorber layer are adjusted from 100 to 1000 nanometer to obtain the effect of the absorber layer with the in-device simulation, while the other parameters are constant that are given in table 1 and 2. JC 20.47 is achieved when the thickness is 400 nanometer, is mostly the larger absorption coefficient of the perovskite. The increased recombination of free charge carrier is in the thicker absorber layer may be responsible for the steady drop in VOC. The higher series resistance could be explained the decreased value of fill factor with regard to absorb thickness. Furthermore, PSC power conversion efficiency rise firstly and peak 12.79% at 400 nanometer and then fall as absorber thickness rise. The absorber thickness is less than the charge carrier diffusion length. As a result, majority of charge carrier reach the electrode and increasing the power conversion efficiency. But for the thick absorber layer, recombination occurs and therefore power conversion efficiency fall as the thickness increase. These are the conclusion. By optimize the value of absorber thickness, the defect density of perovskite material, the maximum value of power conversion efficiency is obtained as 12.79% and with the JSC of 20.47 and VOC is 0.807 volt and fill factor is 77.42%. These findings suggest that this lead-free perovskite solar cell could be visible option for the reaching high efficiency while being toxic-free.
Very good. Thank you. Thank you, Sarita. It was really nice. Next is Pankaj Didwania. Pankaj, are you ready?
Yes, sir.
Please.
Stop sharing.
Sarita, please stop sharing. It's
Yes,
a request to Sarita. Sarita Yadav, please stop share. Yeah. Pankaj, now you can share your screen and finish within 3 minutes, please.
Yes, sir. Yes, sir. Yes, sir. If my screen is visible to you, sir?
No. Click to share screen. Green button of share screen.
Oh.
Yeah. Okay. Now yes, it is visible.
Okay.
Please finish within 3 minutes.
Yes, sir.
Go ahead.
Good evening, sir. My title for the paper presentation is the spectroscopic properties of the praseodymium doped in zinc, lithium, calcium, potassium, niobate, phosphate glass. Now, sir, I have prepared my glass sample containing the P2O5, zinc oxide, lithium oxide, calcium oxide, potassium oxide, niobium dioxide, and praseodymium, where I have changed the mole percentage of the rare earth elements so that I can obtain various type of spectra like the FTIR, absorption and excitation spectra. Sample was prepared using the melt quenching technique, and the amorphous nature of the prepared glass sample was confirmed by the X-ray diffraction. Optical absorption, excitation, and fluorescence spectra was recorded at the room temperature, and judge of intensity parameters are also concluded. So I have used the melt quenching technique for the preparation of the glass sample, and there was working temperature of the 1175 degrees centigrade for the preparation of glass sample. Here I'm showing my result of the sample glass is the. Here the XRD pattern of the prepared sample glass, which shows no sharp Rex peak but only a broad diffuse bump around the low angle region, confirms that the amorphous nature of the glass sample. And the absorption spectra is shown here. There is 8 absorption bands which is observed from the ground state level to the excited state. Now, from the absorption spectra, Judge-Oefeld intensity parameters are also concluded for the 3 types of samples containing the amount of praseodymium is the 1 mole %, 1.5 mole %, and the 2 mole %. Now, in conclusion, there is 3 types of samples was prepared where the various mole amount of the rare molecules, which shows that the value of stimulated emission cross-section is found to be maximum for the transitions 3p node to the 3f2 for the glass sample, ZLC PNP, zinc, lithium, calcium, potassium, niobate, phosphate glass, suggesting that the glass sample where the mole amount of the praseodymium is 1% is the better compared to the other 2 class systems, which is praseodymium 1.5 and the praseodymium 2 mole %. So I have prepared my sample and characterization was done by the absorption spectra, FTIR spectra, and the excitation spectra, which are shown here.
Very good, very good. Nice, Pankaj. You are doing good work. You presented very nicely. Thank you. Now you can stop your presentation.
Okay, sir.
So anybody left who wants to present in this session? In this session, we have 16 presentation from the participants. And let me thanks to our keynote speakers, Professor H.C. Jain and Professor Shashi Prabha for their address to our participants. And thanks to all the participants, with my colleagues, the chairperson of this particular session, Professor Aishman Goswami, and my colleagues, Dr. Ram Nivas and Dr. Sneha Sudha, and our colleague rapporteurs, Dr. Ujma and Tanu Kumari. We thank you to all, and let me congratulate to the organizing secretaries, Dr. Rana Pratap and Vidya Prakash Arya, for their planning and organizing this conference, and also thanks to our principal, Professor S.M. Sharma sir, for giving the permission to organize this conference. Thank you. If you have any, sorry, because we were late by 1 hour, so maybe we have not got that sufficient time or sufficient atmosphere to discuss many things. But if you have any queries, you want to share anything, you can share. Over to Ved Prakashji and Rana Pratapji. Please, sir.
आनंद जी, हेलो
सर। जी सर।
तो अभी सेशन कंप्लीट हो गया सर?
हाँ सर, सेशन कंप्लीट हो गया।
थैंक यू वेरी मच, बहुत बहुत बधाई। हम तो सोच रहे थे शायद 7 बजेंगे, आपने टाइम से पूरा कर दिया। और सभी अपने साथियों को बहुत बहुत धन्यवाद कि दे आर कनेक्टेड with this seminar since morning till now. Now let us leave and join the seminar today by 10 a.m. Thank you very much. Jai Hind.
Thank you, sir, and a lot of congratulations.
Thank you, sir. Thank you.